and the practical also in the afternoon. So let me take the attendance. Basama Alatkatti, fine, good. Pramod, yeah. Ullas, always late. Sridhar, yeah. So please be in time because already resource person has came. Sharanapakuri, fine. Niranjan, yeah. Bharat, late. Shivputra, Krishna Reddy, yeah. Mantesh PS, Sahana, Prakash, yeah. Priya, yeah. Shweta, Kamalabai, Nagaj, fine. Narappa, Sidramappa, Harishyam, yeah. Mahesh, Ravi Kumar P, Aralarsan. Sir.
They will pass. Yesterday afternoon, sir. Permission, with permission.
Logging in.
So once again, very good morning to all of you. So today we have with us Mr. Shivkumar HG and Mithun. So both were background from the drone sections. So one is having his own startup, another one is a manufacturer. So they have both unmanned ground vehicle, unmanned aerial vehicle, a vast experience. So today's first class, so on behalf of our participants and on behalf of our university, first of all I welcome Mr. Shivkumar sir and also Mithun sir for this national level training program. So for the first session, today's class is Mr. Shivkumar sir, who is going to deliver a talk on introduction to drones and applications. Let me briefly introduce about Mr. Shivkumar sir. Shivkumar HG, who is born in 1984, okay, so he's basically now staying at Bangalore. So he is a DGCA certified remote pilot instructor, okay, and also a remote pilot certificate holder also. He's having both, so instructor and as well as a DGCA pilot certificate. He did his BE mechanical engineer from Rama Institute of Engineering, Vishweshwar Institute of Technology. Then he did his MSc in mechanical engineering at Sweden. Okay. So then he's having basically with related to the mechanics work with related to the drones. He has a lot of technical front like structure analysis, UAV conceptual design and development, basically drones. Then finite element methods, then R&D aerospace and agriculture equipments, then analysis, then composite structures. So these are its technical front, what exactly is doing. With respect to the management aspects, the new product development, initiating a startup, and the strategic investment, then futuristic technologies, then product requirement analysis. So I think he has visited more than 6 countries with related to this UAV especially. So last week when I contacted him again, he was in, I think sir, you were in Dubai last week. Hong Kong. He was in Hong Kong with related to this activity. Sir, we are very fortunate to have you this training program. So once again, on behalf of participants, I welcome you for this training program, and I will hand over the mic to you. So please, sir. So one more announcement is, so we have live YouTube record. So many of the institutions, students, and they're watching also. So again, I will send the link. So if anybody is interested at your institution, let them watch. Okay. So we have 24 video. That's a live session for the all the
Today we are just trying to share our experience and whatever knowledge we have gained. We want to share our knowledge related to drones. And important thing is there is lot of labor related activities going on, especially in the farming sector. In current days, a lot of people are also coming from the rural villages to urban cities for job. And also the labor wages and all is increasing. So people are finding how we can labor related activity, repeated activity, tedious activity. So in that way, mechanization plays an important role in agriculture as well as any other labor. If you want to do any cleaning of roads, houses, sowing the seeds, harvesting, everything. So whenever there is a repeated activity, they need lot of mechanization plays an important role. What is everyone is able to understand English, or you need to mix little Kannada? English, fine. So in that way, when we look into mechanization, machines plays an important role. Same like tractors, sprayers came. Now, the drones is placing a eminent role in various applications, not only agriculture, in various applications. So, what is this drones? Drone is nothing but a flying object. It's a robot which can fly. These robots are unmanned robots. Means there is no human sitting inside to operate these robots. When it comes to aerial robots which can fly, we call it as UAV, unmanned aircraft vehicle. When it comes with a proper ground station, control system, all those things, we call it as unmanned aircraft systems. A very common layman word is called as drones. Where these drones were first used, if you can see, even a balloon is a flying object. A gas balloon is a flying object. These gas balloons are used for weather forecast. Same way, in 1800s, French were the first people used gas balloons to drop bombs against the sometimes we want to fly against the wind speed or where we want. So we want to control how the drone should do. So in that way, the first drones were used in defense application. In 1959, the drones were first used by the US aircrafts people, because whenever in the warfare, if we lose an aircraft, arms, ammunitions, the country or the government won't question much. Like in a sense, it's our duty to protect our country. But if we lose any persons or army staff, then it's a major concern, especially human lives into consideration. So they used, why can't we utilize drones in defense applications, warfare? That's a place where drones started. This unmanned air vehicles were usually two types. It can be mechanical, in the sense the remote pilot sits and tries to control it manually, and also if we try to keep on flying it manually, it becomes too laborious. Like every time we need to have our attention there. So in order to avoid too much attention and reduce the number of human errors, they made it as autonomous. Whenever, even in our normal commercial aircrafts, let's say you fly from Bangalore to Delhi, or Belgaum to Delhi or something, the pilot initially when he wants to take off, he takes off, but afterwards he tries to keep it in auto flight, so that the too much attention of the pilot can also be reduced. So the autopilot helps us a lot in doing laborious flying activities. Why these drones are important? Have you anywhere seen earlier drones in your day-to-day life? Marriages. You may see that white color or a black color small drones. What they do, they try to capture some photos. You usually see on the stage, in the center of the stage, you may see photographer, he captures the photo. But when he captures that photo, he is able to cover only partial height of the stage, right? Not the whole thing. But now there is a lot of background design being done on the stage. They want to capture it and give a very perspective. So when you want to capture more area, it's better to take the camera back and play. When he wants to take camera too back, he cannot stand and he need to use a stick. So that's where it plays an important role, especially in capturing the videos, photos. The drones are able to capture in a broader overall picture. So when you try to capture photo, we can give more enough details. Same thing happens in movies. When they want to capture overall view, when they want to capture huge building, big towers, hills, all those things, they use drones. So drones as very helpful in especially videographic applications. So when you capture on a higher height, on a greater height, so we can give more information in the videos. So that helps a lot, especially in videography applications. Same way, if there is any capturing of wind turbine or mobile tower inspection, drones are able to do a lot of application, especially in visual application. It helps us to see what is the situation there, what's happening, how big is the object, and there's a lot of software where we can use to measure the object height, altitude, all those things. And rather than capturing, we need to use stick, we may not get a better picture. And also, let's say we need to capture a 30-floor building video. So there's no other better object to capture if capturing the whole building. So drones are very easier to capture and easy to deploy. You may see in earlier days, they were using a track kind of thing to make a videos. So one person used to pull the vehicle on the track and they used to make a photo. So establishing all those things takes 5-6 manpower labors, it takes more time, but deploying a drone is hardly a 5 to 6 minutes activity. So in that way, it has reduced the cost of application, capturing the photo. Same way, drones are very easier to fly and less investment when it comes to videography capturing. Same way in aircraft, rather than using a whole big Sukhoi aircraft or MiG-21 or ALH helicopters, drones are very, cost-wise it's very cheaper. So the investment is less in drones when we want to make sure that application will happen. So drones has a various easier and faster and low cost. And let's say in Japan there was a uranium nuclear power plant. There was an uranium water leak Okay, so a lot of people are hesitant to go inside that area. They don't want to get exposed to those radio waves. So in that situation, we cannot send humans. So drones can go to this location and check what's happening there. Can use some sensor instruments and check what is nuclear radiations are emitted there. So in that way, wherever there is dangerous situation, maybe there's a fire, maybe there is a poisonous gas leak. So at those locations, drone can be deployed and we can capture the data, whatever as per our requirement. It can be visuals, it can be uh, density of what is the poisonous gas, what is the amount of poisonous gas leak there. Such scenarios, these drones will help. It can be ground robots, it can be aerial robots. Generically, we call it as drones. So this helps a lot when there is a dangerous environment condition, risk, and if you want to capture any photos from a higher level, so we can't climb and capture it. So if we use manual people, it's very tough. So in that situation, drones plays a huge supportive applications in flying and such. There are various applications of drone. Maybe one thing you have seen is aerial photography, and in movies and in marriages. But there are many other applications. I will explain you some few case studies. The next one is, because you are from the agricultural university background, you might have been very familiar with the agricultural drones. When it comes to agriculture applications, you might see presently people are using knapsack sprayer, power sprayers. In knapsacks, they use almost like 200 liters of water to spray for 1 acre. And the time they consume is usually in a manual labor, 1.5 hours to 2 hours. If they use power sprayers with 50 cc petrol engine, they may use 1 hour, 1.2 hours like that. But the amount of water from 200 liters, it has reduced to 100 liters. Usually around 100 liters they use to spray. But when it comes to the agricultural drones, they use only 10 liters to spray for 1 acre. But at one time, 6 to 7 minutes is enough to spray for 1 acre. So there is a drastic level of water consumption from 200 liters to 10 liters. Second thing, the amount of time required, like 1.5 to 2 hours, it has reduced to 6 minutes. Especially these drones are very helpful in quick pest eradication approaches. Like let's say within next 4-5 days, we are expecting some rain. There's a fungus attack, and farmers has huge areas. Maybe let's say 20 acres of farm he has to cover. One is labor issues. He cannot find good laborers. Second one is exposure of chemicals to the man, so they need to avoid it. And there are certain crops like paddy or sugarcane. They cannot enter inside, and they cannot cover it in a very vast rate. So drone plays an important role in spraying. So it's very helpful in agriculture application. Second one is electrical companies. You may see from Sharavati or any power grid, the power is transmitted from the main hub to the cities, or where we from the residual housing applications. So when the power transforms from the main center to here, there's a lot of power losses. Second thing is, when they use these power lines, there are a lot of ceramic plates in the high tension poles. So these gets heated up, and their annual maintenance is very tough. You cannot disconnect the power line and you try to check visual inspection. So these drones are flown close to these power lines. We can visually check what is the situation, especially when there is any natural calamities, too much hurricane, or this power line gets corroded. That's one thing. Second one is if there is any physical damage on the power lines. So we cannot have humans to climb and check. So we can use these drones and do visual inspection. And if there is any heat dissipation within the power line, we can use thermal cameras and check what is the heat dissipated. Is there any power short kind of thing. In forest service and forestry, whenever there is a, especially 2.5-3 years back, there was a fire hazard in Nagrole. And same recently it happened in Gujarat also. So when they use these drones, we will come to know which side the fire is increasing, which part of the forest is getting more catch fire, which because of the wind side, we need to check which part of the hill there is more fire is extended. So we can avoid those areas rather than fighting at the place where we are along the wind. We can fight against the wind, so that we can reduce the amount of destruction of forest because of the fires. and we can see what is the aerial picture, where it's growing, how much area has been damaged. So in this way, drones are very helpful in fire hazards. Now, people are also trying to build bigger payload drones where we can drop the fire retardant chemicals on these forest area. And also, the same drones can also be used for afforestation. We can use dropping of seeds in the forest area, especially just before one first rain. We can drop these seeds where we cannot climb over the hill, so we can use these drones to do afforestation. Gas and oil pipelines. Whenever there is this distribution of oil and gas lines, water lines, so we need to check, inspect. Visual inspection is always there. For example, I'll give a case study. In Russia, there is an oil gas line between Slovakia to Russia. So it's like around 150 kilometers gas pipeline. And those environment is exposed to 30 to 40 degrees sunlight also, and minus 15 degree snow also. So every time they cannot go with harsh environment. So they want to use these kind of drones to follow through this power line and check is there any tampering or is there any gas pipeline. So they use visual cameras and thermal cameras to check the health status of these power line, oil lines. Information service, like whenever you want to capture any crowd, when you want to capture any photo, when you want to capture the elevation of the cities, we can use these drones. In major metropolitan cities like Bangalore, Calcutta, New York and all, there's a lot of traffic jam going to happen. So with using these aerial views, we can check where the traffic jam is going on. For example, if there's any VIP people are coming, they need to check what is the situation upcoming. Let's say if there's one junction, what is the traffic situation in the next junction? They can use these drones for doing VIP convoy. Recently in Andhra Pradesh for Jagan Mohan Reddy, they used drones for taking the convey in the traffic junction cities. And police authorities, let's say there's a mob violence, they need to check who is the miscriminant. Now a lot of AI based cameras have come. So if the culprit has a database is already stored in the police database, whenever they are using the live video, whenever there's a mob violence going on, they can easily check who is the culprit is in the mob. Like if he's there, they capture these photos, they cross check with their database, and they'll come to know who is a person in the crowd. So police uses a lot of things, especially for drones. And for example, in Bangalore, they use for in the time of New Year parties, if there's any mob violence, if there's any mischief happening. So they use drones for by the police department. River authorities, for example, you need to build a dam in between the hills. They need to check what is, if the dam is built, what is the elevation of the water increased. If the water elevation is increased, how much water will submerge the previous villages or the backwaters. So they use a concept called bathymetry. So we use in-depth water analysis. By using this, we will come to know if we build a dam, let's say, for example, a 70 meters dam. So if we try to reserve so much of amount of water, depending on the elevation of this geographical location, we'll come to know what is the water can be stored in the dam and what is the villages or location gets drowned in the water. Those things will help in establishing what is the right amount of height to be built. So it gives a first-hand information for the civil construction people to what height they need to build. And also nowadays, these drones can also be used to create a 3D mapping. For example, now if you might have got property card from the government of India. You'll come to know what is your site layout, what is the geographical location. Drones are used in mapping application, especially all the metropolitan cities, smart cities. Now drones are being used to do mapping. So the city municipality people will come to know what is the areas built in the city, which property has a 3-floor building, which property has a ground floor, which property is vacant. So based on the elevation of the building, they will come to know what is the amount of tax needs to be collected from the people. Some people say there is a vacant site, but in actually if there is a 3-floor building, by the drone capturing photo, they'll come to know there is a 3-floor building. You need to pay, let's say 10,000. You need to pay 30,000 for 3 acres, 3 floors. So in that way, it's very helpful in tax collecting municipality application. So there are a lot of applications. Drones is not one. They're trying to utilize like mobile tower inspection we can use, power line inspection we can use, wind turbine inspection we can use. And even in agriculture, we can use even the drones for crop scanning. We can using the NDVI cameras, we can evaluate what is the amount of vegetative index covered. Based on it, we can check what is the yield going to happen. And if let's say there is a lot of yellowishing of cover, there is a nitrogen deficiency, we'll come to know overall. For example, if there is a farmer with 50 acres, 10 acres, 100 acres, we'll come to know how much nitrogen deficiency the crop is. So effectively we can apply to those specific location the fertilizer. So we can effectively utilize the amount of fertilizer application using these NDVI cameras in drones. So when it comes to these drones, we need to understand when it comes to drones, we need to understand what are the different types of drones are there. So in drones, there are various types of applications. One is called as multi-rotor. My voice is audible, right? One is called as multi-rotor. Multi-rotor in the sense, the name we can break those words, multi, it's multiple. Rotor is the one which rotates. So there are more rotors in a multi-rotor. The next one is fixed wing. Fixed wing is the one which you regularly fly aircrafts. Same way it has wings fixed. Only it has a rotating part which creates the thrust. The next one is the single rotor helicopter. In the single rotor helicopters, it has only one. We use tail rotor. And the next one is fixed wing hybrid VTOL. Let's come from the again first. In multi-rotor, these multi-rotors are very helpful in takeoffing from the same location. You can take off vertically from the same location. You don't need any track or a proper track to take off compared to the fixed wing. When it comes to fixed wing, you need a proper takeoff, a complete runway, then you need to take off. So it consumes more space. Whereas a multi-rotor can take off in the same location at a standstill location. So literally if the aircraft is 5 feet by 5 feet, you need only max 10 feet by 10 feet to take off. There is no need of any proper runway required. Whereas a single rotor helicopter, again same like multi-rotor, but in single rotor it has one rotor. There is no like multiple rotors. And in single rotor, it's a little tough to operate. In the control systems, it's little more complicated. Whereas the multi-rotor is pretty easier compared to any other aircraft. That's why the reason multi-rotor was a very much easy to reach out to more people, and easy to learn and easy to fly. When it comes to fixed wing, the fixed wing is literally a multi-rotor only. In the vertical takeoff, to take off from the ground location to a certain height, it acts as a multi-rotor. When it goes in the forward flight, the front or the back motor it's not visible. You have a mouse pointer? Can I use mouse pointer there? It's wireless, it's not. Well, I have wireless mouse. So when it comes to fixed wing now, here there are multiple rotors. Okay, here you have only one single pusher. If it's the rotor is on the back, it calls as pusher. If it's in the front, it calls front one. So in fixed wing, this is the main one rotor which tries to push it. Okay, whereas in multi-rotor, all this will take the equal load and tries to give a lift. When it comes to helicopter, the main rotor will try to take the upward lift, and the tail rotor will help in controlling the direction. If you need to turn right, the tail rotor will help us to turn right or left. When it comes to the fixed wing hybrid, there are 4 rotors which acts as a multi-rotor. To take off, these 4 will run first, then once it goes, it has a transition of flight from vertical takeoff, it suddenly move forward. To move forward, there is a back one more rotor. So why nowadays this VTOL, hybrid VTOL is becoming more famous? The reason is, here this multi-rotor is always standing against the gravity. If you leave an object, it comes down, right? So there is excess amount of power being consumed by the multi-rotor. It don't have any kind of wings to glide. Here in the fixed wing, you have a wings which can glide. Even when you have less power, you can use the control surface and slowly we can land it. But whereas in multi-rotor, if there is less power, immediately it will drop down. So combining these two combinations, they have made this. So in the forward flight, the wings also help in contributes in the flight. The pusher motor will help in going for a forward flight. So the battery optimization is better in the vertical takeoff and landing. VTOL means vertical takeoff, you can take off and land. So it's literally a fixed wing hybrid VTOL. It's a combination of these both. So in this way, there are some 4 types of aircraft being available in the drones. So it mainly depends on what is your application. For example, you need to drop your payload. You can drop with fixed wing also and with multi-rotor also. For example, there is a company called Zipline in Rwanda and African countries. They are using to drop the vaccines from the bloods from the main medicine distribution center to various hospitals. So when they use this, you need to drop in the hospital vicinity. For example, you have a park in front of your building, right? If you drop there, people can take it and go. For example, that's in that places they use this kind of fixed wing. Okay. In recently, I have personally seen there is a food delivery application happened in Shenzhen. So you cannot use this. You cannot drop the food somewhere suddenly. It may fall in your neighbor house also. So you need to drop your food in a dedicated location only. So at that time, you need multi-rotor. For example, they are using fixed wing VTOL to do mapping applications. And for example, you need to do medical delivery drones, vaccine delivery drones they are using for 50-60 kilometers. So at that time, when your endurance, when you want to fly for longer time, they are using this VTOL. When it's in a short span of, let's say, maybe 10 kilometers, 5 kilometers delivery application, they use multi-rotor. So depending on the applications, we need to selectively choose the different configuration and how far we need to fly and how much weight we need to carry and what is the battery endurance required, what is the motors required. Those factors comes into our mind based on our application. We need to understand first what is the application required, then we need to choose the configuration.
So what is the full form for VTOL?
Vertical takeoff and landing. So it can take off vertically and land vertically.
Sir,
Any questions still?
with respect to the fixed wing hybrid, the source of power supply, when you are saying endurance will be needs more endurance.
Correct.
So we have real types that means both battery and as well as fuel type.
See,
Hybrid mode.
I'll give an example. In fixed wing, for example, if you want to fly for 30 minutes, even 8000 mAh battery is good enough. But if you want to fly for 30 minutes with the same around 10 kg aircraft, here you need up to 22,000 mAh battery. Almost 2.5 times the battery is consumed there. Whereas you want to build with the same kind, even 12,000, 14,000 is good enough. So if you want, but here you cannot land vertically, no? So here this optimized power, you can land vertically, and with little power, but here it consumes more power. But if you want to stand still, for example, irrespective of wind, you want to stand still. For example, marriage photography, you can't keep on running and capturing the photo. You need to stand still and then capture a photo. You need to capture, let's say, you need to do a power line inspection. You need to do mobile tower inspection. You need to stand still and then capture a photo. Whereas this fixed wing cannot stand still. It will be minimum 14 to 15 meter per second is a minimum speed. If it comes down, immediately it will drop down. So multi-rotor will try to stand against the gravity. So it depends on application. Okay, can I proceed further? Yeah. Earlier is the configuration based on its based on its weight, based on its speed, based on its flying rate. So why DGC is more concerned about these drones? These whenever for any national safety act, see there is one international ICAO, International Civil Aviation Organization, is the one which controls and establishes a proper set of rules which is uniform throughout the world. So they have set a form lines. So based on those lines, DGCA, Directorate General of Civil Aviation, has regularized the rules in India. And again here, if we need to fly anything, Airport Authority of India (AAI) is a organization which is given permission to even Indian Air Force or any people, civil aviation people, to fly. So again under this, and this Aircraft Authority of India is the main person to control the airspace. Their control is to see which aircraft is flying in India, which flying object is entering in India, all those things. So whenever we want to fly, we need to meet these DGCA regulations as per the standard norms. So the DGCA is beyond certain weight limit, then we call it as nano. So for example, here they are termed as any drone which is less than 250 grams. Most of the toy drones and non-dangerous drone, we can say, or non-commercial drone, it's more like a hobby drones. Whatever drones you might see in your flying apps, like Flipkart, Amazon, or any shops, those drone weighs less than 250 grams. It's called as nano drone, and these drones cannot fly more than 15 meters per second. So if these drones are within those limits, and if these drones are flying below 15 meters, around 50 feet, we can term this drone as nano drones. And they are not supposed to fly beyond 100 meters or visual line of sight. The pilot should fly always in his line of sight. Until unless he can see, he should fly. He should not fly beyond it. So any drones in India has to be flown within your line of sight. Means as long as you can see, you can use it. If you are not supposed to fly beyond the line of sight, if you fly beyond line of sight, you need to undergo certain amount of training. Next one is the micro drones. All our major camera drones comes in this category. These drones weighs from 250 grams to 2 kg. Most of the drones which you might have seen in marriages, for example, if you have seen the black color, it's a Mavic series DJI drone. It weighs around 750 to 900 grams. If you have seen a white Phantom drone, it's called as DJI Phantom. It comes around 1.2 to 1.4 kg. And these micro category drones should weigh between 250 grams to 2 kg, and it should fly below 60 meters, literally 200 feet. You are not supposed to fly above 200 feet. And again, the speed is 25 meters per second. But major concern is the weight and what height you fly and what location you fly. Next comes the small category drones. Those drones weighing more than 2 kg and less than 25 kilos. And your flying height is limited to 120 meters, around 400 feet. You are not supposed to cross 400 feet, and you are supposed to fly within your line of sight. And the drone weight should be between 2 kg to 25 kg. Even if there is a slight increase, let's say 25.2 kg also, it comes to the next category, medium category. If you fly beyond that flying height, you go to the next category. Again, it comes to the medium category, any drone which weighs from 25 kg to 150 kg. If the drone is more than 150 kg, it's called as large category drones. So when you want to fly any drones, we call these aircrafts, of flying objects as drones up to 500 kg. As per Aircraft Act 1934, there's a list of rules set in 1934. So until 500 kg, if the flying object can be categorized as drones. If you go more than 500 kg, you need to follow aircraft rules as well as DGC drone rules. For example, now they started with pesticide application, power line inspection. Then they told we will do delivery drones. Delivery drones for food is okay, medicine is okay. But now they told why can't we deliver even the humans? Because whenever there is any road accident, why can't we airlift? Because helicopters cannot be landed each and every places. So we can use a small multi-rotor aircraft. We can lift the people and take him to the nearest hospital. That's the requirement going to happen in next 3 to 4 years. The reason is, especially in cities like Bangalore, Mumbai, there is a lot of traffic jam. So taking the patients to the nearest hospital is very tough. Like most of the cases, like heart patient, or first 20 minutes is very golden hour for giving the treatment for the patients. So we need to somehow take the patient and give treatment within the next 20 minutes. So how we can take him? So drones will be the major applications for air delivery or like air ambulance applications. So these are all defense application, agriculture. Now drones will be major application in health sector. So these are the categories of drone based on size, flying height, speed, what height we can fly. So when it comes to drones, I just want to give an idea. What are the important part in an aircraft? These propellers tries to push the air and tries to create a lift. I'll be telling further how this Bernoulli's principle is a scientific fact which has been used to generate lift. And what drives the propeller? How the propellers gets the thrust? It be used by a motor below it. There is a motor below it. So by the power, these motors will try to rotate. Here what I have shown is a quadcopter with very generic photographic camera. But what you see in the front is an agriculture drone. So whenever here it's quad means 4 arms. There four arms are used to fly a drone. Whereas here what we see in the front is a hexacopter. Hexa means six rotors are used to fly. What you see here, these are the main rotors. These are the one which tries to rotate and tries to generate a lift. And below you can see motors. Again in these motors there are as a generic file, you might have seen two types of motors. One is brushed motor and brushless motor. Here they use brushless motor. You might have seen toy motors in your houses. The kids will play. And there's a one standard steel shaft in between. There will be two small copper coils which will be used. These are called brushes. When it starts rotating, there will be a lot of wear and tear is going to happen in brushes. Whereas here, there is no such brushed coil going to happen. Here, in the outer runner, if you open the motors, I have bought some samples, I will show you later. There are magnets placed on the outrunner. So whenever we give right cover, the coils are placed in the center. So depending on the electromagnetic induction going to happen, the magnetism takes place and the rotor starts rotating. Compared to the brushless motor and brushing motor, the RPM in the brushless motor is more and there is less friction. Cost wise, these are more costly, but performance wise, these are better than the brush motor. I will try to give more examples as it may be. Next one is the ESC, electronic speed controller. In this motors, the ESC is placed here in the bottom. So the electronic speed controller gets a signal from the flight controllers. From there, the signal, the motors gets actuated. So depending on the flight controller, the signal gets actuated, then the motor starts rotating. Some samples. So easy.
Which one is ESC?
So here it's inbuilt. I bought the samples. I will show you. Because what happens is the flight control is placed in between. Flight control is called as the brain of the. Based on the remote, when we try to use the joystick side. For example, RPM depends on kV rating. Let's say here this is a 150 kV motor. For example, the input voltage for this is around 48 to 52 volt. Assume it as 50 volt. We cannot have a 50 volt. And what 50 volt it rotates. For example, for every 1 volt of supply, this will have 150 RPM. If you supply 50 volts into 150, you may get around 7,500 to 12,000 RPM it rotates. But every time our aircraft will not run at full max RPM. For example, if you say in your car mileage 200 km, will not run at 200. We usually run at 100, 120. So we run these motors at 55 to 60% is an average value. We cannot overload the motors. So usually 55 to 60, max 70% of its capacity we need to run the motors. Sir, if you check any motors, the internet is connected to this one. the nut has come out or not, we can easily come to know all these things. Because these power lines are exposed to sunlight, harsh wind. If these power lines are close to the coastal problem, they'll be subjected to corrosion. When corrosion happens, there'll be a lot of fasteners getting loosed. So we need to check, by using the drones, we need not stop the operation of the power line, right? We can easily check how this, without any stopping the operation, we can using drones, we can check, we can inspect these power lines. The previous one was with the normal daylight camera. The next one we have used thermal cameras. For example, wherever there are lux, there will be certain heating elements. So by this, we can check which part is getting heated. When you look on the right thermal images, you can see spot 1, spot 2, spot 3. You can see all are at 64, 67, 69 degree, but spot 4 is at 98 degree, means there is something going wrong in that place. Usually the temperature is 60 to 69, 64 to 69, but why spot 4 is 98 degrees? That is giving some doubt that compared to others, that's getting overheat there. So we can give an idea that this part is getting overheated, you need to replace it. Same way in electrical companies, we can use thermal cameras and the regular cameras, we can inspect and give an idea what has to be replaced, all those things. Same way in solar panel inspection. See, generally in 5 megawatt solar panel, there are 26,000 solar panels. We cannot go on each and every panel and check whether the power wire is going correctly or not. Is it performing well or not? So India is planning to have almost like 5 megawatts, but now when we cross 100 gigawatts, maintenance is a big headache. So using thermal cameras, we can make an aerial pictorial view of these cameras and check what is the temperature distribution among these. See, for example, in look on the right side, 53, 45, 51, 53. It's a very standard grade of temperatures. But there are some special locations, 72, 71, 81 degrees. Means there is something wrong in that. What is happening technically means, the light is falling on the solar panel. The solar panel using photovoltaic cell, it has to transfer the power from the solar panel generator to the battery. But this is not transferring the power to the battery. Means the power is getting accumulated, the temperature of the solar panel is increasing, the power is getting not being properly transferred. Means there is problem in those specific cells. What we do, we give the geographical location, the GPS lat long location in that. Let's say 1000 panels by 800 panels is there in a grid formation. We will give 361 by 42. They'll go to that solar panel and check what has happened in that. When they directly go there, there may be some solar panel got hit by a stone, power is not disconnected, some power is not getting transferred. So this is a regular maintenance checkup, has to be done once in every 3 months by solar grid people. So thermal cameras helps in understanding where the fault is there, to repair maintenance and effective power. See, the intention of putting solar panel is we need to generate power. If it's not doing proper, that's the where we need to use for maintenance. So drones helps a lot, especially thermal cameras helps a lot in using solar power grid maintenance. Same way like wind turbine inspections, we can we cannot go to that height and climb. Almost 180 feet is one wing of the turbine. So we can inspect using drones with a high resolution cameras. Same like structure inspection, mobile tower inspection, high rise metal towers. You can look here, there, the nut has come out, literally loose. How you can decide? Depending on the shadows we can decide. Some places the angle is bent, some places there is corroded. So by using this we can understand, do we need to replace the nut, do we need to change the structure, all those things. Same way now they are using in warehouse inspection, what is the material loaded. For example, there will be a lot of goods stacked, on that there will be barcode sticker. We need to check whether which material has been placed on the higher rack. So we can use this thermal camera and barcode reader, the same barcode reader which you use in your shops, right? Same thing we can use and check whether which stack has been placed, whether the material has been dispatched or not. And nowadays in Amazon warehouse, whatever the Flipkart, Amazon, they can use small drones and check whether the material has been dispatched or not. Here we have visual inspection in the turbines. If there is any cracks in composites, we can check. These thermal cameras can also be used in forest. For example, if there is any wildlife, smuggling poachers, and recently there were a lot of leopards coming to villages, no? So by using night operation thermal cameras, we can check where location the leopards are been hiding, all those things. Again, when it comes to agriculture, crop scouting like health monitoring, pesticide spraying, seeds dispersing, cattle management, all those things. Cattle management are being used in European countries. Drainage and flood planning, if the city is in the lower area, we can check which part of the city is getting drainage, like over flooded by waters, all those things we can get an idea. Farm topography mapping, for example, if the farm is not uneven, for example, estates in Chikmagalur, let's say they have some 800, 700 acres, which is the right place to put Krishi Honda, which is the right place to put borewell, like that it will be helpful for them. And this numbers I will be explaining later. Coming to the mining application, let's say this is one mining area. We need to extract some manganese. So how much mines or how much ton is extracted, we need to measure daily. So what they do is first they will capture the topography mapping. They do a 3D mapping of the whole structure. Then for next 7 days, they excavate the mines. After excavating the mines, then again they will do one more mapping. So the volumetric change between the earlier mapping and the second mapping will help in how much mines has been extracted from the ore. Something like, for example, the same way, we are doing a construction, let's say Brigade or Purvankara or Shobha developers is doing a construction, big project. They ask for the concrete people and sand people to put some 50 loads of, they may say it's 40, they may put 48 loads, then they say I put 50 ton. They can do a volumetric and check how much volumetric weight of M sand has been placed in the location. So they use all these things and do. These are various applications. I'll just go in a quick way. When it comes to agriculture drone, the important factors we need to consider is the nozzles. Yeah, the intention of using spraying drone is we need to effectively apply the agriculture inputs to the crop. Mainly these are pesticides, fungicides, herbicides, but we don't recommend herbicides. Growth promoters are the very common agri inputs which we spray on the crops. And what is the right way to apply and what is the right quantity to apply is our topic we discuss going to happen now. Different types of nozzles which we use. We have electrostatic nozzle and next one is a double jet nozzle where we have two outputs. Next one is single jet nozzles, and again we have Y-shaped nozzles and we have boom nozzles. So these are various types of nozzles available in the market. When it comes to these nozzles, it's called as T-jet nozzle. This is a company called T-jet has developed these nozzles. What exactly is inside this nozzle? When you try to open the nozzle cap, inside you find a flat nozzle inside. You have one washer, you have a nozzle tip. It has a small flat opening in it. This can be plastic or ceramic, metallic, depending on your applications. So these nozzles will spread the droplets on a V shape, in a V flat shape. And depending on the operating pressure and liquid flow volume, these nozzles will operate, and this has a small internal mesh in it. Why I'm focusing more on this is because farmers don't understand what is the kind of mesh inside it. And nowadays in the market, there are various kind of inputs, which is, for example, SAF powder is a powder based. One is water soluble, one is oil based, one is liquid chemicals. So when the pilot or a drone pilot goes to the field, he need to understand what is the agri input to spray. For example, if it's used powder, this filter will clog. So generally, when we recommend as per for the drone to operate effectively, we recommend contact, not a contact, systemic based chemicals, and completely water soluble or a liquid based chemicals. If you use powders, it's going to clog. If you use too much oily based liquid, it's going to clog. Those are not suitable for these kind of nozzles. In such scenario, we go for a centrifugal nozzles. So the pilot has to be equipped with both the kind of nozzles. Depending on what agri input, he has to switch between the T-jet nozzle to centrifugal nozzles. Because we cannot ask the farmers to change, because whenever we did almost 5 years spray service, in that already the farmer has bought, we can't make him to return it back. So we used to take both the nozzles. If he has bought powder based, go for centrifugal nozzle. If he has bought liquid, then go for straight nozzles. And this discharge amount of liquid flowing through the nozzles depends on what is the pressure and what is the volumetric discharge being done by the pump. We have a pump fitted in the forward, I think you might have seen. So these pumps, sir, shall we rotate this? These pumps has, depending on various capacity, for example 10-liter drone has 5-liter discharge pump in it. ಆ ಕಡೆ ಸರ್, ಈ ಕಡೆ ಫಿಕ್ಸ್ ಮಾಡಿದರೆ ಪಂಪು ತೋರಿಸೋಣ. ಲಿಫ್ಟ್ so here we have a pump which can discharge 5 liter per minute. Now 5 liter per minute, but 5 liter is for a max. Let's say for 10 liter, usually 5 to 6 minutes is the flying time. So if we discharge 2 liter at a 2 to 3 bar, not only discharge is important, it used to have a good pressure in the pipes. Only when it is sufficient pressure, the liquid will discharge in a V shape. It will be a triangle shape. It will be a triangle. If the drone is flying at 1 meter per height, then the swath, the width of the spray will be 1.2 meters. So overall in 1.2 meter, 0.2 meter will be overlapping of this. So 4 meters this drone can cover when it flies at a height of 1.2 to 2 meter from the crop level. So 4 meters. Generally what we do when we cover now, there will be little drift, 4 to 4.5 meters this cover droppage the spraying can happen. The reason is the droplets distribution should be uniform in the crop. But though design, there are external factors like wind drift, forward flying speed. All those are important parameters when we consider for the quality of spray going to happen on the field. See, for example, from the flight controller we tell, please discharge only 20% of the capacity, 30% of the capacity. For example, we usually give 60% discharge rate. Means 3 liter per minute we discharge, but 3 liter will not come because of the internal pressure. No, 2.2 to 2.5 liter will come. Overall, 2.2 liter for this one, pump. When 2 liter comes out of the drone, means half a liter for each nozzle will come. Yeah, like that. If you want higher capacity, like 16 liter drone, means we have to use 8 liter discharge pump. If you want to use discharged 20 liter and 25 liter, this again new pump has come to 12 liter per minute discharge. Like that, depending on the payload capacity tank, we need to increase the pump. Same way, we may also need to increase the nozzles also. We may use double nozzle, or we can put a boom. If you put boom now, we can cover up to 5 meters. Left 1 meter, drone 0.8 meter width. Again one more, like literally boom is only 4 meters. This easily can cover up to 5 to 6 meters. We can cover in the drone itself. That will be very good for paddy applications. 10 liter.
10 liter per acre.
10 liter per acre is good enough. To be frank, some drones in Thailand are using 8 liter per acre. 8 liter.
That is the ultra low volume, means there is any modification in the spraying or normal?
See, yeah, compared to nap packs, when farmer asks, sir, why should I use this? What is the difference between nap pack to here? They will ask. In nap pack sprayer, 400 to 550 micron is a droplet size. Here, 80 to 130 micron is a droplet size. The droplet size will be very fine here. So, they'll ask, then why you are reducing from 200 to 10 liter? See, our intention is what? A droplet should fall on the leaf surface. When the droplet falls, like minute droplets falls on the leaf surface, the stomatal opening which is there now, these droplets are sufficient to enter those porous location. So, these chemicals we use with wetting agent. Silicon based wetting agent we are using so that the viscosity of the water is increased and it gets stick to the leaf surface. The advantage here is when the drone rotates, because of the wake, the leaves are oscillating left and right. So, the chemicals falls on the surface and also the lower part of the surface. So, in that way it will be very advantageous. Second thing is when you spray in the paddy field, now, most of the time when the insects are there, it will also come out because of the wind speed. And they are directly exposed to the chemicals. When you do with the NAPAC sprayer, now, that won't get exposed. Because of the wind drift and wind force, these insects will come up, it will try to fly away, and they are directly getting exposed to these chemicals. So, in that way, these drones will be very effective in killing the insects, especially in the paddy field, all those things.
But in paddy field, due to the wind speed, lodging will also happen.
Not so much, not. So, what we recommend is, do not fly the drone too close to the ground. We will ask the minimum 1.2 to 1.5 feet. Like
Sir, whether this has been used on plantation crops, sir?
like
Arecanut.
is highest here.
How much spray volume
See,
is required?
especially usually the important factors to consider is this is paddy, wheat, maize and all. 10 liter is good enough. But for example, when you take for mango, depending on the vegetative coverage, we need to increase the liquid. In areca, we took around 20 to 25 liter per acre. Per acre. We usually used to take 2.5 flights. But for example, mango plantation, we used to take 3-4 flights, like 40 liters. Because some are 5 years plantation, some are 20-30 years plantation. We need to cover each and every corner, no? So depending on the vegetative coverage, what is the agri input needs to be then we used to dissolve corresponding to the liquid. Then we used to spray.
So 20 to 25 liters within 2 sprays.
Yes.
2 rounds.
So, what's the incidence that is even sir, what is the standard operating protocol
Still lot. See, we did on our own trial basis.
It's only a thumb rule that
Thumb rule we have done. But legally I cannot write on paper. Because when we speak in agriculture university, we have to speak with research data, all those things. But it's our thumb rule. Okay?
And for the what sir was telling, so we particularly for different for herbicide we are using flat pen nozzle.
And here there is plastic tip nozzle, ceramic nozzle, metallic tip nozzles there are.
Flat pen, this is metallic nozzle.
Correct.
And again we are using all. This one is flood jet nozzle, especially for the insecticide and
Conical.
So this is what you use.
This comes in conical form.
Yeah.
Huh.
So again this is exclusive for the nutrients.
And this is anti-drift nozzle. And why they call anti-drift is because the droplets becomes big. Here the droplets are broken into fine pieces, but here the droplet size will becomes in oval in shape, because by the time it drops, there will be no much because of the oval shape of the droplets, it tries to fall down, don't get drifted, carried away by the wind.
Sir, actually you said insects directly exposing to the chemical, they are not going to die actually. Systemic insecticide, only the contaminated tissue it fits means then only it will die.
Correct.
Directly coming into the contact with the chemical, it does not affect the insects.
Correct. Okay.
Only
Only contact will yeah.
may be helpful, but this may not be helpful.
No, like in what is that village? No, correct. What is said is correct. Say for example, for crop we use systemic chemicals, but for insecticides, if they get exposed,
No, sir.
it won't die.
Nowadays chemicals are systemic only.
Okay.
Contact is not that much needed for fungal diseases, other things may be there. But for insecticides, maximum are systemic only.
Okay. No, in Hubli for one sunflower case, there was lot of worm kind of thing. So when we used to use drones, no, these insects used to come on the surface and they used to get more exposed, and we found that they fell. That was feedback given by the farmers. Some. Okay.
Just to clarify, it is not that if we spray the systemic insecticide, when we spray the systemic insecticide and solution will pass on the insect, it will get killed. And systemic means we are talking in terms of the whole plant becoming a seed. So that way we are telling the systemic insecticide.
Only after falling on the inside.
When the insecticide falls on the insect, both the contact as well as systemic insecticide can kill the insect. And advantage over the contact is the systemic, when we spray, the whole plant becomes toxic.
Correct.
And the feeding insect, when it feeds, it will get killed out.
Sir,
It is in
Sir,
terms of
generally-
plant we are.
Okay.
sir, generally spray volume we say 200 liters. What about the concentration? Still they need to be standardized.
That's what is, so we need to.
Now, frankly speaking, standard package of practice has to be decided, like as per the ICAR rules. They say you have to do at 3 geological location and minimum 2 seasons has to be done. So institutions like yours has to be
Actually, I am doing, sir.
fine-tuning
There are
on
some
it.
case studies are there.
But Scott,
Sir is into the engineering field of this one. Related with agriculture case studies will be coming out. There they will be coming out because there the water volume is varying from 10 liter, 15 liter, 20 liters. How it will be useful, and the molecules will go on changes with the logarithmic scale from 0.5 to 3x. For example, if you are taking 1x to 200 liters of water volume per acre. So that logarithmic scale can be varied with respect to the drones. That's what we are evaluating and standardizing that as well. Okay. Now there is no standard rule that the drone you have to take 10 drone with respect to this insecticide. That is the minimum you have to take. What sir was telling 8 liter or 10 liter, that is a minimum requirement to cover with the help of this present the small category drones.
No, I am conveying what, for example, in Thailand, Korea and all, they are using 8 to 10 liters per acre. I am just conveying what is a package of practice being done in other. But when we need to be officially and package of practice be commercially done here, it has to be properly tested by ICAR. So, yeah, and Department of Agriculture rules already has given a circular in the website saying that what will be the wind condition, what is the spraying height, what is the chemicals in it spray. There is a standard protocol being already given open to public. So that document can be referred for doing that. Usually it's available.
That will be presenting in the future classes when it comes to the agriculture. We'll present all the SOPs. Don't worry.
In some cases also, they said that the drones, even 25 liters are used for spraying. Then standard.
No, still they have to standardize it. What is the, for example,
It is under the process.
areca and mango, because depending on the vegetative coverage, the volume increase. If there is less, means we need to reduce.
But in other states like Hyderabad and Telangana, they are saying that, for example, the
Propose it, still it's a draft, not a finalized, like it's a proven thing. And similarly, the agri inputs which we're going to spray, no, it should also be compatible. And farmers are not, farmers in the pack when we use it, no, they have to mention if you spray in drone, what is the right agri input has to be sprayed, with how much liter of water should be sprayed. That has been not officially been in information. Like still it's in a research stage. The product has not been completely emerged as commercial product. So there's a lot of support needs to be given by agriculture, science community, research and farmers and industry. Yeah.
One rule we can cover in
As of
say
now,
10
yeah,
liters,
yeah.
In 8 to 10 minutes, you can cover the 1 acre.
Yeah, yeah.
Less than that also it will cover, not 8.
6 is good, 6 minutes is good. Takeoff and landing another 30-40 seconds.
That is what is the this drone flying speed range from 3 meters to 8 meters. How much of speed will be taken? For example, if you are going for 3 meters, then it will come up to 6 minutes. If you are going with 8 meters per second, then it will come to 4 meters. So that's all. That's why what the sir was telling. See, the molecules again need to be standardized. The CABA regulation has given these are all the molecules can be used under the drones. Many of the private players and the individual players, those who are operating, so they are using, so let us not mention, so the company what they are doing right now. So they are using wherever the recommended dosage is 6, for example, 3 gram per liter. For example, it's a combination of
was system and as well as contact management. Many of the areca they are using 16 blocks. Because the water volume is less, let us go with the high value. So that is not a standard. So because of the high dosage, it is giving good performance. Toxicity, cytotoxicity level, airborne, air density, molecule density, everything has been not standardized. That is what now it is the duty of our scientists to whether, because already many of the corporate companies they are entering based on their molecule. It is all over it again the business. When the value comes down, their market business will be coming down. That's what.
So there are a lot of electrostatic nozzles where the droplets gets electrostatically charged and gets stuck to the surface. And here you have small video in it. You can see the fine droplets covering on the droplets gets break into small pieces.
Charging of the electrostatic today, that electrostatic water, we have to take the power from the battery.
It's some fine battery. And here there is a regular T-jet nozzle. The angle of spray, it's around 110 degree. Again here you have 80 degree, 90, 110. 110 is a very standard angle which we droplets. Here what happens is the spraying swath, means the gap between one nozzle to other nozzle and what height we spray makes an important forecast. And we should make sure that the coincidence should be very less. It should not overlap. So that when it overlaps, there will be more density of chemicals going to fall. So proper care has to be taken on spacing, the row spacing, all those things. Here there are 80 degree, 110 degree, 120 degree nozzle. 50 centimeter, if we are using 110 degree nozzle, 50 centimeter is required between one nozzle to other. The gap between one nozzle to other nozzle is 50 degree. And here there is again the coarse droplet classification. Extremely fine, less than 40 microns. Very fine, 40 to 80 microns. Fine, 80 to 120. 120 to 150 medium, coarse, like that. The droplets gets classification. Here also there is lot of research has to be done. Like what is the optimum droplet size required for a crop to fall. And external factors like temperature, wind also plays an important role in the droplet size. When we open any nozzle, these are important parts which we get in nozzles. Filter, rubber bush, the nozzle tip and the nozzle cap. Here there are different types of nozzles. For depending on herbicides, this data I got it from the manufacturer OEM sheet. Okay, it's not any research activity. I got it from the OEM sheet. So if we need to spray herbicides, fungicides, insecticides, which is the optimum one which we can use. So here we are using a T-jet nozzle. The operating pressure is more than is less than 3 bars. So since we are using a DC 12 volt pump, so and it's like around 24 volt is operating operation voltage. So using T-jet with low pressure, this is optimum for most of the crop. All are good, very good. So we prefer T-jet 110 degrees because it's very common with all the different types of chemicals. There are again anti-drift other types of nozzles also, but these are used in the regular boom nozzles. And once we make spray, how to monitor the quality of these sprays? See, there is a droplet size monitoring software. We use water sensitive papers to evaluate when the droplets falls on the surface. After that, as soon as it falls, it will again expand. There is a factor we need to consider once it falls. See, there is a software called Droplets Dropleaf. You can also download in your mobile. This app name is called as Dropleaf. What we do is, 1 inch by 3 inch water sensitive paper. Once we use water sensitive paper, the leaf size should be 1 inch by 3 inch, and we need to take a high resolution photo and then upload into the software, into the app. This will tell what is the number of droplets fallen there, and since the paper size is 1 inch by 3 inch, based on the coverage, it will tell how many number of droplets, what is the size of the droplets covered, and what is the average of the droplets been there, like that. Based on this, we'll come to know if, for example, fungicides, there should be minimum 10 to 15 droplets fallen on the 1 centimeter by 1 centimeter. We can create a certain standards. Then we can tell whether the insecticides, let's say 15 droplets per centimeter square. Then keeping this as a reference, we need to decide what is our discharge rate, what is the forward speed. We have to go the reverse way. We should make sure that the minimum number of droplets are fallen on the leaf. Keeping this as a reference, we have to come the other way. Which is the right suitable nozzle? What is the optimum speed? What is the optimum height to spray? Like that, we have to do a research. This is an app. It looks like this. Drop leaf. You can scan the photos. It will convert an image. Paper size 3 inch by 1 inch. Then it will convert into image processing. There is again a literature paper in the public available. So here it will tell number of droplets in the area, what is the droplet size, all those things. Yes. In terms of micrometer, we can tell what is the average droplet size, what is the number of droplet size fallen on it. But this has to be placed at different location. Top of the leaf, middle of the leaf, lower part of the leaf, and average of 5-6 places we have to take.
Usually when we are standardizing, we are keeping because when we are taking altitude of 1 meter, we are placing this water sensitive paper at 30 centimeter and 10 centimeter.
Correct, okay.
So here at the 2 stages will be available.
Yeah. For example,
Is it okay?
how we did, frankly speaking, how we did in open field, before going to crop, we fixed 1 acre of area. Every swath, 1 meter, we stood a stand of 1 meter, let's say crop height is 1 meter, we took a stand and placed a horizontal paper. Okay. Then we place it every 1 swath row. Okay. That is drone performance. But how the droplet is going to fall on actual crop? For example, maize. Maize, the leaf is inclined, no? So the droplets may fall. So we stick the leaf the same angle at 5-6 places, like all top 5-6 locations, 1 leaf, middle 1 leaf, lower part of the leaf. Whether really some farmers complain that this droplets will not come to the lower part of the leaf. So even tested that, like usually 80 to 90% droplets falls on the top leaf, 35-40% on the middle, then 15-20% on the down. So if we need to increase the droplet size to reach the lower surface, then reduce the drone speed. If you reduce the drone speed, the downwash of the propeller will be more and the droplets will reach more in the lower part of the leaf. For example, mango has apical leaves, more we need to put growth promoters on the top surface of the leaf. So there is more fruits and flowers going to happen in the top. No? So we spray very fast only in the top. It need not reach if we need to reach more in the bottom part of the leaf, then we need to reduce the slow down and then do it.
And especially when it sprays, main stream is inclined, no? And the water droplets of dropping will just...
Yeah, once we are using systemic, no, once it touches the leaf, it gets absorbed. And in Brazil, they have done a lot of research on application of drones in maize. They have done a lot of work. Compared it, the power or the content of the leaf is more than 8 to 9 days in the crop. They have literally given all the documents. So, sorry for phytotoxicity, no? Like the amount of residue in the kind of chemical which is absorbed in the plant, which is for an extended period compared to the normal spray, like 3 to 4 days more. Yeah. Like let's say for every 15 days you need to spray, you can increase the gap of 20-25 days.
The frequency can
The frequency can be reduced like that. See, what causes poor performance is corrosion of nozzle tip, clogging of nozzles. We need to keep at the right optimum pressure. We need to use even a pressure gauge, whether the drone is performing well or not. Who will take care of this? Drone technician has to take care of all those things. For every 100 acres or 50 acres, we need to do our periodic checks for the drone. Yes. Drone spraying also. ಇದಾಗಿದೆ ಸರ್ ಆಟೋ ಪೈಲಟ್ ಆಲ್ ದೋಸ್ ಥಿಂಗ್ಸ್ ಇದಾಗಿಲ್ಲ ಸರ್. So there are certain standard operation procedures when we need to use drones in agriculture. For example, we are not supposed to fly on cattle field. We are not supposed to fly the drones on open public. We are not supposed to fly on water bodies, and we need to fly only in the daytime. There are certain standards being given. When we fly these agriculture drones, there are 3 different types. Like one is manual, where the complete control is with the pilot. One is autopilot. In the autopilot, what he does is he puts the corner grids, the boundaries of the farm, and he says within this area you need to fly. Then we need to define what is the height of the drone should be flown, what is the forward speed of the drone should be flown, and how much volume of liquid can be discharged. Like for example, if I say 1 acre, let's say when he maps, he gets 1 acre of area to be covered. We can tell discharge 10 liter for 1 acre. If you want 5 liter, we can tell only discharge pump of 5 liter of liquid for 1 acre. So we can have controlled discharge of liquid. If you want 20, we can go for 20. So the technology is that we can control effective uniform distribution of agri input for the selective area. And what height? Let's say 2 meters, 1 meter is a crop height, and again another 1.5 meter we can. So 2.5 meter from the ground level. If I say try to stick from 2.5 meter from the ground level, it tries to constantly hover at the same height. So in that way, autopiloting is there. So what are the important safety factors? Obstacle sensors, front and back, because here the drone goes pitch forward, then again it rolls to the right, and again when it comes back, then this sensor will work. If you put only one obstacle sensor, then when you go to the next line, it should rotate. What happens is when it tries to rotate in the corner of the farm, it consumes more time. Like 8 to 10 seconds is required to turn for the next line. But here, just roll right and roll back. Within 1.5 seconds, it comes back. So the battery consumption is reduced by adding one more radar, and also for safety. Earlier there was only one front radar. Now they have added back radar. Still, advanced drone have 360-degree radar. So here they will be having a rotating sensor which will try to rotate an obstacle in all the 360 degrees. Because the disadvantage here is in the roll right, you don't have an radars. You don't have any obstacle sensor which can detect. In 360-degree radar, it has an advantage in it. And next one is track the field and fixing the coordinates. For example, you have mango. Mango is not uniformly distributed throughout the farm, right? You have one location, it has a canopy, then again in the gap, there's a gap between one trees to other. So we need not switch on the pump each and every place. We can only switch on at selective places. So depending on the canopy location, we can have a artificial intelligence cameras. If there is a canopy, only then switch on the pump. Otherwise, do not switch on the pump, because hardly 10 liter of chemical is there. So it should switch on where and only where it's required. So at that location, we can use software and algorithm and we can do it. Manual flying completely in the pilot's control, and the drone should be always flown in visual line of sight. But power consumption is more compared to the other flights because it's not optimized, and it also depends on the fly skill of the pilot. Most of the time, certain things, what happens is the uniform speed, the pitch forward will not be uniform in the manual flight. Sometimes he goes forward, he goes to 4 meters, suddenly he goes to 2 meters. So the pump discharge will be not so uniform. But if he is a very well trained pilot, he tries to keep the pitch angle constant. He doesn't tries to reduce, something like how you give throttle. No? If you keep on giving, increasing, reducing, your car will jerk. But if you keep a constant throttle, then you can have a uniform spray. But the practical problems in Indian scenario is there are a lot of trees in the corner. There will be suddenly, this year there will be a small tree, but when you come back after 1 year, no, it will be a very big tree. So when we try to put autopilot, then suddenly they say last year I have used in the same field, you use the same app, then suddenly it goes and hits the tree. That's the problem. Last year there may be no power line, this year some power line has come, so it will hit the power line. So as soon as the pilot goes to the field, please go around the farm once, check any power line, any mobile towers are installed, what are the bigger trees, what height is the right to spray, is there any pond or something. After inspection, then he has to start the sprays. In autopiloting, he has to check the presets, power consumption is optimum, and in autopilot, obstacle and terrain sensor is must, they need to. And in autopilot, what happens is, if there is any signal loss, in manual you can bring back, but in autopilot if there is a signal loss, we have to make sure that what is your home point, what is your home location, we have to be fed in the road. If there is a signal loss, immediately it comes back and lands by itself automatically. If it doesn't feed that home point, either it will hang there only or it will land there only. What happens is, as soon as if it lands, there are two things. In case of signal loss, land there or hang on there where you are or come back to home. If you tell land there itself, then it doesn't know whether there is a water, there is a tree, then suddenly it lands on that itself. So we need to check prior to the flight, what is the input feed we are given. I would prefer usually in the most of the autonomous flight, either return back and land or hang there itself. See, track field and coordinates, like wherever we are recorded, we can manually get it sprayed. It's like a semi-autonomous flights. And here in the spraying, we usually prefer systemic chemicals rather than contact. And we also use adjuvants like wetting agent. And more than important is, we also need to check what is the pH value of the water. If it's too salt or too acidic water, we need to also check. That also plays an important role in dissolving the waters, the inputs in the liquid. And what was a package of practice which we regularly use? For example, pesticides recommended is 2 ml, micronutrients is 1.5 ml per liter. Apex sprayer, what we use is, let's say 400 liter of water we use, so 2 ml into 200 liters, 400 ml of pesticides, 1.5 ml into 200, 300 ml of micronutrients. Same way in power sprayer also, let's say for example 175 liter, depending on that we multiply it. When it comes to the drone, 2 ml per liter, so we input, let's say 240 ml and 180 ml is a recommended chemical for that acre. Let's say 10 liter is a liquid, so 9.6 or 9.7 liter is a liquid and another 250, 300 ml is a chemical we spray. But again there is a contradiction. How can you mix, when we are mixing a 200 liter, how are you mixing to a 10 liter? Will it create scorching? I think answer is with you only. You have to only advise and give. Because we are technology people. Frankly speaking, we are not the right people to advise on this. We need a support from technical people and the research industry and advisors. Yeah, total volume 10 liter.
Including the chemical.
Yes, because certain information I collect from, so for example, there's one drone company called DJI. They are almost 85% of the market capture. I spoke with their farmers who are spraying already in Thailand. 400 ml of input is there, they use 9.6 liter of water, 400 ml of agri input. Like that they are using it. And again here, especially like paddy field and all, the insects and all become proactive in the evening time. So there they are allowed to fly in night. But in our Indian scenario, still they are not allowed to fly in night time. So things have changed a lot. And here 10 liter is a very standard drone. But the latest market scenario is they are using 10 liter drone only for spraying. But in Thailand, Korea now, They are even using for seed spreading activity. For example, 50 kg of urea needs to be dispersed. They take the drone with 50 kg capacity. They pour 50 kg urea. Same tank they'll use even for dispersal with few modification like seed spreader mechanism they'll remove. They'll fix the pump mechanism. Yes, yes. So 30, 40, 50 is very much famous in the eastern part of Asia. Now India has introduced 10 liter drone to the market. 30, 40, 30. Ma'am, this can carry 10 kg. Na? They are using now 30 kg, 40 kg, 50 kg. Like a 25 kg seeds are fertilizer packages. They directly pour 25 kg packet into it.
But that will be broadcasted, right?
Yeah.
We are also free operation of this. One is for sowing, one is for spraying, another one is for capturing.
For sowing, what?
Actually, even paddy line sowing is also
House.
recently going on.
Like semi-germinated seeds, they can disperse it.
One PSA to dismantle this can.
We can remove the pump and can, and we can fix the spreader.
It is having three options.
Now the latest design is tank from the top loading. So they remove the tank and they'll fix one more tank. And here the tank is fixed. Either you put herbicide, insecticide, same tank. There we can have a separate tank for herbicides and separate. Yeah. See, things are evolving. Like they are the front runner. We need to slowly catch that speed. That's it. No, for example, let's say 120 liter of liquid is used for a standard practice. For example, 400 to be frank, this is our standard practice we did earlier. Rather than putting 400, we used to put only 60% of the chemical. That was very much effective. So it was saving 30 to 40% for the farmers. So compared to the NAPAC sprayer, 30% chemical can be reduced. Yeah, and it's effective also. That's not an official statement, but again it has to be. Quantity of agri input is reduced. Yeah, there will be a contradiction because a lot of agri input sellers, they don't want to lose their 40% business, so they may not support. Efficiency is increased, and the concentration of chemical entering the crop is increased, and it's effective. But only thing is it should be properly decided by the research people. Yes, 60% is good, 70% is good. 2 ml for 200 liters, 400 ml. Instead of putting 400 ml, we'll put only 240 ml.
60% of the molecule is recommended.
Yeah. But 60 or 70, we should do a test on it and then confirm it. Sir? Still working. Okay. Sir, you have any questions? As per my knowledge, I just shared my knowledge on what is drones. I think already DGCA regulations has been done. So how it works, what are the operation challenges? Economic point of view, per day if you cover 20 acres is good, but many cases, few of my pilots, earlier company, they have covered 60, 50 acres and all. I know one people with 16 liter drone, they have covered 80 acres per day with one day. So 80 acres if they do really good job. And 30 liters drone can cover up to 200 acres. The thing is, we need so much acres in India, but India is more fragmented. 10 liter is very optimum model for Indian market.
I have two questions. One, you will say that you are monitoring the towers and mobile towers with the drone. What we have told that you don't take your drones to near the high voltage towers and mobile towers. So how you manage that thing?
See, because of the electromagnetic induction signals, they will be having problem. Okay. Now what we do, we don't go too close to the mobile towers. For example, there are certain 30x zoom cameras, which has high resolution camera, which we can zoom. So we have certain softwares called Pix4D scan, which is meant for mobile tower inspection. Based on geographical location, it makes a circular radius of 50 meter away from the mobile tower. It captures photos at certain height. It doesn't go too close. We use high resolution cameras and capture those photos and then create a 3D model. Metal towers, power line wires, we should not go to. The reason is there is lot of electromagnetic induction is going to happen that will hamper the IMUs. not too close. At least 10 to 15 feet away we need to be from the. But farmer won't listen, because who will spray below the power line, they will ask. Then again we need to bring the NAPEX spray. You are telling we will eradicate NAPEX, then how you going to do it? So we have to improvise. See, what has happened is, in the flight control we need to do a concept called shielding. Means we have to protect the EMI interference with the FC. So little again from the technology point of view, we have to improvise how to protect the EMI interference with the FC. That has to be done now.
And second thing is, sir, you are telling that 30, 40 liter capacity drone are now, they have good efficiency to more acres.
Yeah.
But what 10 liter why ICR is given? Because the total weight capacity 25 kg. When the drone is above the crop, it not disturb the plant. If the drone size increases, it the average of that drone shake the plant and damage the plant.
No,
damage the crop.
no. At that time, the swath will increase. The flying height will increase.
But also increase, losses also increases. So 10 liter is why it is sufficient, or the formulation is very good, or if all the drone companies keep the 10 liter, the formulation the companies, the fertilizer or insecticide companies give in the 10 liter calibration, they give their formulation, and the damages to the crop, because if we are taking the horticulture crop, that it is enough, that it is no matter. But we are going on soybean, then cotton, they are very
Sensitive
crop if they are flowering. So they may damage.
So we need to make sure that the downwash of the wind should not damage the crop. Correct?
Yeah.
So it depends on how much air is pushing downwards. Correct? So if I use a bigger propeller, then the force acting downwards will increase. That's what you mean to say, right? Yeah. At that time we'll increase the flying height. Instead of 1.25 meter, we may increase up to 2 or 3 meters. So by the time air comes down, it pushes down, that air force will reduce as the height increases. So, which one? Correct. It also depends on what weather condition we are flying. For example, in Thailand, they are flying early in the morning, so wind drift will be less, like that. So if you want to cover more area, then there will be more two number of flights. It will be tough. So let's see how market is going, then we'll check it.
Sir, which are all the crop you have underwent spraying?
Sir, any crop, I'll just example, when farmer asks now, will tell, any crop which is uniformly spread all around the farm, like wheat, paddy, sugarcane, jowar, maize. So even if it's a drift or not, tomorrow it may go 2 meters away, but it will still fall on the crop itself. So uniformly spread crops is good for drones. For example, when we are doing a specific row crops, then we need to follow that. Still, the AI algorithm line following has not yet come in the Indian market as of now. So we need to choose where the crops is uniformly spread. That works really well.
So you have got 40,000 acres of.
Huh.
At that time, how do you spray? In manual mode or automatic?
Yes, this is one common challenge. In paddy field, when there is no power line, autonomous spraying works well. In some places where there's a lot of too many trees, obstacles, then we go for manual spray. Yeah. Because as a pilot, as an employee, I need to protect my drone first. I need to safely fly and land the drone. So at the same time, we need to help the farmers. So we have to carefully fly and land the drone.
Because what happens is, in automatic mode, the trace is 15 feet from the
Correct.
road. So the leaves, at the last leaves, they detect that and they stop there.
Correct,
They
correct.
consume the time.
And it hangs there only, then the battery keeps on depleting. So we usually go for manual flight. Practically 85 to 90% of the flights is manual. And see, if at all it should be autonomous now, there should be a 360-degree radar. Even if it's 10 mm, 1 centimeter obstacle should detect. When it goes to that level, then we can rely on the mechanism. No obstacle field means then we can work. For example, in northern part of Karnataka, cotton fields, there are like 20, 30 acres, no obstacle, no trees, nothing. That works really well. Maize fields also works. Because northern part of Karnataka, there is vast land and they are all dependent on rain only. There is no borewell pump sets. Yes, yeah. So at that places, our pilots enjoy the flight. Like,
I have to take the something, suppose I'm spraying
Sure, madam. Yeah. You contact us because we can contact you the right people. There are a lot of pilots. See, basically, I'm from Veeresh Technology Private Limited. Now first I did develop drone. Then I worked in drone service company previous. Now I'm sourcing all drone components to individual entrepreneurs. So you tell me which district, I will connect the pilot there itself. Yeah. So they will coordinate with you in that local districts like that.
Phone number, sir.
Yes. 99. 1 minute. Sorry, you can take 988. 988 09 82336. I'll repeat 988 09 82336. If you add that number in WhatsApp now, all my products catalog will come. So generally what I do is, lot of farmers, lot of youngsters, entrepreneurs contact me. So usually I support them in providing drone components, technical support, all those things. Any other questions here? If there's no questions, I will, you can contact me anytime. And if you want any literature, documents and all, I can share that. Thank you.
Thank you very much, sir. So it was almost a very good sessions we spent from morning 10 o'clock. So related to because sir is from IMSA, that means he is a design developer and fabricator. So that's what he has explained, how the agriculture drone sprays and its working principles, and how your commands, and as well as total and as well as pitch forward, how it will be influencing on the discharging of your particularly pesticides and all those things. That plays a very, very important role. I think, sir, on behalf of the participants, so the participants I forgot to tell during morning. So participants are from the outside the district and outside the state also. So they are total 28 participants and 2 are from corporate sectors. One is Zuari Hub, another one is from ITC. Today is joining, sir, because he's busy schedule. So many of the corporates, they are interested to join this course. So once we have told the resource persons, particularly yours and as well as Mithun, I got good references from the corporates that they want to attend that one.
Now most of the agriculture roles are coming from small category, medium category. So recently I got even have completed, YY is left out, medium category instructor, because as in the drone keeps on capacity increasing now, it will come to medium category. So we are also starting a RPTO, remote maritime technology in Bangalore, to do the medium category training, because a lot of people are thought that only small will be done, but it's not. Things will keep on capacity will increase. So if anyone is interested, please contact me. I can get a proper license and what is the standard protocol of package of practice to be done. And July 15 to 27th we are doing workshop. Nothing commercial. We are generally the university invites us for every once in a year. We do training. If anyone is interested, if you want to depute your students, you can contact the university.
Thank you, sir, for delivering the great lectures related to the drones in agriculture. On behalf of the organizers and our university, a token of love for presenting. So I request our senior participant, R. Larson, sir, to hand over this token of love from the organizers. Certificate, you show certificate. Thank you, sir. Shukumar, sir. So now we'll break for the lunch. Now time is 1:38 in my watch. So we'll reassemble here by 2:15. Okay, 2:15. So because Mithun, sir, so now before lunch we are in the aerial. Now we are coming to the ground. So unmanned aerial vehicle now completed. Now we are coming to unmanned ground vehicle.
Okay, sir is expertise and he is a CEO and founder of Xmatic. I will introduce once after his session starts. Okay, we'll break for lunch, we'll reassemble.
ಅದೇ PPT ಮಾಡುತ್ತಾರೆ ಇದು ಮಾಡ್ತಾರೆ ಹುಡುಗರು ಹಂಗೆ ಮಾಡ್ಕೊಂಬರ್ತಾರೆ ಈಗ ಏನೇನು ಬಟ್ ನಾವು ಇಲ್ಲಿ ಬಂದ್ರೆ ನಾವು ಬೇರೆ
So good afternoon to all of you once again. So I hope everybody has lunch. So now again, it's a very difficult task for the uh, resource person to hold continuously up to 4:30 to be engaged continuous. Now, so the second resource person. So let me introduce Mithun SK. So was born on 13th August 1988. So okay, basically is a automobile engineering from VIT University, then MS in automotive product design engineering from the United Kingdom, UK. So he is basically designated right now as an managing director and the CEO of Xmatic Innovation Private Limited. He is having a technical sprint with a new product designing and also conceptual design of unmanned ground, air and as well as surface vehicle. So DGCA certified drone instructor. Okay, he's having the management aspect skills like new product development, initiating startup, product opportunity gap analysis, and the VC investment. So he got 2 patents with related to the products in the field of new product development. So let us congratulate on behalf of our participants to Mithun sir. So his experience is a trainee engineer in BEML Limited, and he was assistant professor at MS Ramaya College and a manager at new product development in drone industry. Now at present he is a MD and CEO of Xmatic Innovation Private Limited. Sir, with your vast knowledge, it's very happy to have you in this national level training program. So once again, on behalf of the organizers and the university, so we welcome you for this 10 days drone training, especially for the scientists and above cadre. So the participants are from the different districts and also different states, Maharashtra and Kerala, and tomorrow one more is joining from ITC, basically is working in Andhra. So the people are diversified groups. They are engineers, they are into the agriculture, all are background of the agriculture. That is one positive, and all are doctorates, are every doctorates. So hence it is a good that now, right now, we are not into the UAV because now we are stepping into the UAV, but still now we are in the ground level vehicle movement like tractors and whatever it may be. So what is the advance what you have developed? So like to share the information. So I call upon you for the dais and share the information, sir. Thank you.
Thank you very much for the wonderful opportunity to speak with the all doctors, professors here. So actually here only 2 people who don't have the doctor degrees, myself and Shivkumar here. Okay. So basically myself and Shivkumar have started our career in MS Ramaya, School of Advanced Studies as assistant professor. We were there for more than 5 years and worked together in the automotive and aeronautical engineering department. So the advantage with Ramaya, why we have moved to Ramaya is we were working closely with the industry there. That was the new concept, some modular concept academics was there. And all syllabus were taken from the Coventry University, UK. So that's how we started working there. And we were in the part of some industry projects, and research also was good. That was the first milestone for us, like first step towards the product development. Our Vice Chancellor at that time was Professor S.R. Shankapal, was more into the new product development. He was forcing us to do some product development. These UGV, whatever we are doing now, we have done almost 10 years back in Ramaya University. To the Dharwad University, we have taken on project and we have done there. So these all ideas were coming from there itself. Whatever the new ideas comes, we used to go there and propose, and he is assigning some students for taking up that projects. And that is not like that. We don't like here. We may get some fund from different organizations, but it is not like that. University has to fund us, our student has to fund us. Like that it has to work. So like that, the new product idea has, means we started practicing the development of new products. Then Shukumar moved to drone industry, and I followed him. Then I split, both of us splitted there. So we both of us taken instructor training almost same time. And then he started his own business, I started my own business. So this is the Xmatic Innovations. So idea behind this is even I'm basically from Shumaga district only. So from the agriculture background, we have some areca nut, and I have seen the actual ground difficulties in the agriculture, what they are facing. So timely availability of the labor, skilled labors are not there, cost involving, and it's highly, we can't predict anything, whether the market, nothing is in the control of the farmers in this case. Price, so everything is depending on some other people, and they are living on the others' decision. And moreover, they get salary once in a year. So whereas at least we got every month, they'll get an income every year once, and protecting that is a very, very important. That's how the idea of automation comes into my mind. I just wanted to work on the automation for the agriculture. Like that, we started with this company to work on the, for one is agriculture sector, and the second one is the defense sector we wanted to move. So this is the main, our product is unmanned ground vehicle. How this idea has come into picture is because of the drone only. See, drone always flying, so always Shukumar will be in the air only. I'm a very down to earth person. So the similar idea, why can't we make this on the ground? That's what the idea first started. One more thing is drone. I used to see the drone from the long time, but the dependency on the other countries is very, very much high. So it may be a hidden truth, or we have to tell that we are depending on other countries on the most of these components. Now people started working here, and they're building, even Shukumar is coming up with his own frame and drone. So like that, now it is started, but we are actually depending on the other countries, neighboring countries. So like that, see, and also I have seen lot of demerits of the drone as well. So if we go with for the areca nut crop, we cannot spray under the canopy. That was the problem. And the grapes, vineyard, we can't use it because we have to spray from the bottom. So there are certain areas where we can't use the drone also. There are the limitations. So how to overcome that limitations? Then we thought some vehicle should be there on the ground. So that will solve the demerits of this. Where the ground vehicle cannot reach, the drone is there. So like that, to work together, we both started. He moved towards the aerial vehicle, and towards the ground vehicle. So like that, Xmatic Innovations has started. Basically, our product portfolio, if you go through that, so unmanned ground vehicle, unmanned aerial vehicle. Aerial vehicle, we have a tie-up with Viresh Technologies Private Limited. So whatever the technical requirements can, we work together. And unmanned surface vehicle, that is the next. Surface vehicle is nothing but a boats or water vehicle and underwater vehicle. That also unmanned is very required. Requirement is there to, for the defense sector and protecting our borders, because almost more than 70%, 75% we are surrounded by the water. So protecting the country from the enemies, that is also very important, and some rescue operations. So a lot of other things are there. We have to have the unmanned surface vehicles as well. So like that, it is started. So just before starting just moving to the unmanned ground vehicle or robotics, just I wanted to spend some time on the precision agriculture. Why we need the robotics, why we need the automation. This all the first layer is the precision agriculture. Everyone is moving towards the precision agriculture. We are wasting lot of time, lots of agri inputs. Lot of problems are there by using the traditional agriculture here. So we have to move towards the precision agriculture. What is the first step of the precision agriculture is the adopting the few new technologies. So like that, the way I'm telling is, before talking about the UGV, I'll just go through the precision. What is precision agriculture? How it is, what is the requirement of that? So before going that, what is the, how I can compare the unmanned ground vehicle with the unmanned aerial vehicle. So similarly, whatever you have seen, there are a lot of components, you know, the motor, propeller, flight controller, so all are there. In the same way, UGV, unmanned ground vehicle, all these components will come. Whatever the flight controller we call here, which is a brain of the drone, there we have a vehicle control unit, VCU, we call it as a VCU, that controls the complete vehicle. So advantage with our product here is the vehicle control unit is completely developed in-house. All algorithms, board design, everything has done in-house. So the advantage with the UGV compared to the UAV is we can test it easily. Testing the drone on the air, it's developing the flight controller is not so easy, but developing the controller for the UGV is better than the drone. That's the one thing. Same way, we have a motor is there. Here we use the BLDC motor, there also BSDC or PMSM motors we use. We have the speed controller, ECS is there. There we will be having a motor control unit. So both the motors are same, size is bigger. So here usually the input is DC volt, DC, you know DC and AC current, right? So it's a DC is the input, but our ECS converts that to the AC. When you look into the speed controller, the output is 3 wires there. Input is 2 wires and output is 3 wires. See, the input is from the battery 2 wires. The output is 3 wires. So it's a phase conversion will happen. The same principle we use in the electric vehicles also, UGV also. UGV has a similarity with the UAV as well as the electric vehicles also. This is actually a converter. More than that, it converts the 2-phase to the 3-phase current and use that, so technically speaking. Similarly, for the unmanned ground vehicle, we'll be having the motor control unit. Okay. Apart from that, we have an obstacle sensor. There also it's an obstacle sensor. So that is, here we have completely autonomous application can be done, grid farming can be done. So same way we can do it there itself. So all are similar but a different structure. Its frame is different, that frame is different. Here the propeller which will give the thrust to that, there it is a motor and the tire. We call it as a powertrain for that. Application wise, we have a sprayer here. Sprayer can be attached there. We can have a seed spreader here, that also can be done there. So similar, just why I'm telling this similarity means, so whole technology or the components wise, there are a lot of similarity. When it comes to the working, here your yaw, roll, pitch, that's a different, and there it is a different. That's the only difference we have, difference between the UAV and the UGV. Okay. Now, just I'll move into the topics. So before going to the robotics in agriculture automation, I just want to talk about the precision agriculture. What is precision agriculture? I think most of you are aware of the precision agriculture. So I'll just go like, okay. So let's start with the introduction, advantages. We call some 5 R's of precision farming. What are the technologies and present practices in and the future trends. So there are a lot of UGVs, robotics are available, plucking, harvesting one, or spraying robots. A lot of other robots are there. We can see some videos also. And the role of educational institutions, because you know we can scan the crop and using the multispectral cameras. Based on that, we can apply the change the quantity of the fertilizer application. So all these things we speak here, but can it be conveyed to the farmers? Very difficult. If I go with these slides, it will not entertain us. So how to convey that? At a one single step, we cannot go with the complete all these things. So it's a step-by-step procedure. First, we should make them use machines like UAV and UGVs. Once they start using, they have to practice that. Then we'll introduce some artificial intelligence to this. Maybe the IoT, in getting the crop data from the cloud, and based on weather condition can be analyzed. When spraying has to be given, that direct message should go to the farmers. So these are all the advanced or intelligence to be given to the machines. That has to happen. So that's where the role of the educational institutions are very required in this case. So we have to make the farmers to use the machines, and then we have to start improving the machine. First, they have to start using the machine, then we have to improve the machines. Then the technology will reach the farmers. And some case studies we can discuss. So what is precision agriculture? So it's as name suggests, so precisely we have to work on that. It's a calculated manner, what is exactly required. So in one form, there will be difference in the soil condition. So every part of the land, we have to identify what is the condition of the soil. So like that, the implements, fertilizer or whatever, we have to give based on the requirement, rather than wasting inputs. So it may be the fertilizer, micronutrients, or even the watering. Now, there are a lot of companies are working on the automated irrigation systems. So how to give the intelligence to that? Again, those products are also available in the market. We can analyze what is the water content. So what is the weather condition? So when we have to give the water to the plants. So this analysis has to happen, and we have to work on that. So this is what we call it as a precision agriculture. And the advantage is we can save a lot of time, money, effort, and carbon footprints also we can bring down. So spending a lot of fertilizers wherever it is not required. So these things we can bring down. Okay, so precision farming, why it is required? It requires because the productivity can be increased because of this, and soil degradation, that's the one of the important thing that can be controlled in this, and use of chemical can be brought down, and efficient use of water resources, so that's also important thing, and we can improve the quantity, quality, and reduce the cost of the production in the agriculture crops. So this is the reason why we have to go with the precision farming. The coming to the advantages, see, I'm talking this precision agriculture. At the end, what are the end result? But how we are going to implement is the second thing. That's a very difficult task here. So one is the, as I told, the water, fertilizers, herbicides, pesticides, all the use of these chemicals can be reduced. Water resources can be protected. And I'll come to this point later. Just I'll talk with the technologies, what are there. So coming to the technology here, so lot of technology which is involved in the UA drone also. Like we have a GPS and GIS system. I'll come to that. GPS is positioning, exact position. We can get up to 2.5 centimeter exact position now. So understanding the position and the information. GPS is a positioning system, and this is a geographical information system. What is the information? What is the soil condition? How much irrigation is required to that? So these kind of information, and also the altitude, topology of the land. So these kind of things can be understand with this. And there are certain technologies are there, like auto steer. So anybody is aware of auto steer? It's a separate attachment can be fit into the tractors. So what we do, so we have a land and path planning they do. Maybe the land preparation for the requirement of land preparation, maybe spraying activities and all. So that the pathing can be planned in this, and by attaching this auto steer to the existing tractors. So it is like a system which tractor. We can set the speed of the tractor. We can mount that on the this device on the steering, and using the device we can map the geofencing. Using the geofencing, we can map the boundary, and we can plan the path and automate the tractor. It will just go in that path and come. Same application, same tractor we are using, but we are automating it, so that the advantage is the driver error can be reduced in this. So exactly he may not maintain the exact swath or the path. So that can be reduced in this. That is the advantage. And the skilled labor or resource may not be required. So these are the technologies which precisely we can address the problem. And wireless telemetry, what is happening and all, we can sit on one place and we can analyze it, what is happening there. And this is also very important, variable rate technology, like the spraying, fertilizer application, whatever, based on the crop health. So there will be, it's like an unmanned ground vehicle. The vehicle will be there. The front, it will scan the crop based on the crop health. The behind there will be a sprayer or fertilizer application unit will be there that will act based on the sensor feedback. So what is the crop health? Based on the crop health, I will spray more agri inputs or less agri inputs, or what is required that can be sprayed based on that. So that's called variable rate technology. Then the artificial intelligence is This is actually artificial intelligence combining this, what is the geographical area, what has happened to the previous in the same land conditions. That's all data they will be having. That process, and using artificial intelligence, they can act accordingly. And remote sensing. Remote sensing is the one main, as Shivkumar discussed in the morning. So it's complete the scanning or the understanding of the land using the drone. So either remote sensing will happen through the drone or the satellite images. They will take that data, and processing its data is very difficult actually. So whole precision farming depends on the quality of data collection and analysis. So we cannot simply act without the data. We have to have the proper data, and that collecting data is the first difficult task, and processing that is also very, very important. So understanding what is that, it may be the multispectral camera, what is the difference in color, the different color, what does it tell? What is the deficiency in that particular area? So those understanding, the processing data is very important. Once processing the data is happen, and we'll act accordingly, maybe the variable rate technology or different thing. So based on this data, we take action. And after that, we have to monitor yield as well, whether which is improving the yield or not. So all these things, so if it is a complete package, which will help us to reduce the cost and can be productive and all these things. But are we able to convince this to the farmers? So we can tell here in the class with the sessions and all, but convincing this thing to the farmers is very difficult. So as we are discussing during our lunch, accepting the tractor or these kind of machines, they took more than decades of time. So but these technologies, how they are accepting this, that is a very important. So just I'll go with these technologies. What is these technologies, so that we will understand the benefit of and the advantages of precision agriculture in this. Okay. So global positioning system. So GPS, it's a concept of GPS is nothing but exact position we will get. So up to we have few centimeters, 1 centimeter, 2 centimeter accuracy GPS are there. So using this GPS advantage for our UGV. I'll just link this with our technology as well. Accuracy, these things and all, we have up to 1 meter, 2 meter accuracy is there in the drone. So, but there are the GPS up to 2 centimeter accuracy we'll get in India also.
If you install
RTK.
real-time current updates, you can get up to 2 seconds.
What happens, that RTK is a device, we'll calibrate and keep it, it's like a tripod only, we'll keep in one place, it will exactly take the location of this and start communicating with the controller, and from this the reference point, from this reference point it will take exactly the coordinates. So up to 2 centimeter accuracy is possible. Again, attaining 2 centimeter is very, if we get that using our vehicles, means UGV, it's very easy. Exactly 2 centimeter accuracy will have. Every corner of the land we can go, or whatever has to be done, that can be done. But the cost again here. So the RTK, it will cost in lakhs, but whether the farmer is able to take that or purchase that is a very difficult thing. It's up to 1 meter is there. 1 meter. But still there are some without RTK also is there, but the problem is satellite count. How much satellite count? Usually drone training, they will tell you have to count the number of satellites. 12 satellite, 18 satellite should be there. No, that's the accuracy of the GPS will get based on that. What happens if the 1 meter or 2 meter accuracy, I'll ask my UGV to go in this line, it will go there. So it is practically very difficult to use those kind of thing without the accuracy. But GPS accuracy is the mandatory, but what we can do in this case is the RTK, more than RTK, what we are doing in our case, UGV, we are going to the agriculture land and we are just marking the boundary and feeding that to the vehicle, and we will plan the path. It's a one-time activity. If we do that activity, and we'll take one reference point, and always our vehicle should start from that reference point. It will take this as the reference point, and that whole path planning will happen through that, so that we can avoid the cost of the RTK module in that case. That's how we are working now. So how to reduce that cost? If the RTK cost comes down, then we are ready without those kind of hurdles. You can just download a KML file and give it. It will take the grid and it will go as per the requirement. Okay. So after getting the GPS coordinates and geographic information also very much required. So this is the understanding the soil moisture content, pH rate, all this, the previous history of the ground and the topology of the farmland. So all these things is the comes under the geographic information system. So this can be taken through the drone survey, satellite images, all these things we get the data, and GIS information is useful when we processed it properly. Very important. Only having the information no use. How we process, how we understand, how we give the solution. All three things are very important when it comes to the GIS. And grid sampling. This I think, so you are very much aware. So how to get the grid sampling. So they will make the grid on the land. So in each and every grid, they will take the samples, they will understand it, and they'll feed it to the system controller. That's where the artificial intelligence comes into picture. So exact the ground reality will come into, we can understand through the grid sampling. Our controller will analyze that and how to act. When the vehicle comes to that particular location, what kind of the inputs has to given. When it changes the grid, what is the soil condition and what kind of input has to be given. Maybe it will change the quantity, basically quantity, or even in further if you go, the dilution, how much the water has to be added, what is the percentage to be maintained. So these are the advanced things can be done in this case. And auto split, this is what I told. So you can see the device here. This is the steering kind of device, and this is the controller, and this is the whole user interface. So that steering will be mounted on the tractor steering, and you can plan the grid, how the tractor has to move and start, and keep the tractor in a constant speed. That option is available in all the nowadays tractor. So you just start, it will move in the planned direction. It's a very simple technology and very useful one. So people, now it is actually, I don't know, in India, hardly there is no manufacturer of it, but at least the technology is very good in this.
So any modification needed, sir?
Nothing. We just fix it. Yeah, auto steer is, we are controlling only steering. So it will not brake. If something comes in the front, you will not apply the brake. So those are all the intelligence to be given to the machines, like keeping some obstacle sensors or other intelligence to be given to the controller. But a very basic thing, it will handle the steering. That's all. And the advantage is, if the tractor is filled with complete diesel, day and night it will work. No need of human involvement in this.
Sir, is it possible to apply existing tractors?
Yes, that's what. That unit is for the existing tractor only. We take that unit fixed to the tractor steering, and using the device, you map it and give it. It will go.
Is it available here in our country?
Yes, we can, and we are actually in touch with the company to get the technology. And yeah, maybe they are also. I think we have videos of that. Yeah, cost is little high. Even I am trying to get the negotiate the cost and have the technology here. So what happens? Our UGP 100% we have developed. The first thing what I am trying to do is I will get the technology and understand if we can make in-house. That's the first priority. The second priority, if it is little difficult, we'll procure them. We'll try to understand down the line, and we'll make by ourselves. This is a very simple technology. Cost, I am not aware. Even just to tell you the approximate cost also, I am not aware. It should be less than a lakh. That's what I am expecting. I don't know.
Between 80 and 1 lakh.
Yeah, it should be, because very simple thing. Only for the innovation you have to pay here, not for the bill of material cost.
In Raichur also for the rotavator, during packing operation we have done that.
That's similar. Okay. What is your
Automatically without any man sitting on the
intervention, it is going. Okay.
Also, Mahindra is also having same technology, sir, in their tractor. They are now taking the demonstration. Recently near our university,
okay,
they have demonstrated that thing.
Demonstrated.
They have put that device
Same device.
Atom state the precise GPS location for that.
That RTK,
RTK they have put at the corner. And tractor is.
Correct. The RTK is mandatory. That is the only thing which is a hurdle for us to make it completely. Whatever the UGV we have parked outside, so complete electronics we have a support. We have a inbuilt GPS. Everything is there. Just to automate, we have to have the RTK with us. So that's a for demonstration to make YouTube videos. We have the facility. But when it comes to the practical application, it's very difficult. That's how we are working on that.
What's the extent of RTK?
Real-time kinematics. Real-time kinematics. That will increase the accuracy of the GPS. Grid sampling, it's like a one geographical area to other geographical area, the soil condition will vary. No? It's a labor tedious work, but once we get the data, we can use that, and based on that, whatever remote sensing we do, we can map it, we can understand the condition of the soil through the satellite. Size varies here, 1 meter, up to 1 meter by 1 meter also there is. 1 meter, 2 meter by 2 meter, so like that. Here what happens, one area to another area, the difference in soil condition we can understand. Yes? No, first is sampling has to be taken from the ground only, and they will understand the patterns. So based on the pattern, they map with the satellite images how the pattern changes, so that they can keep the track for for few years. Maybe every 4 to 5 years, this sampling has to repeat it continuously.
Satellite images also available, but the satellite depth
Route routing is very much necessary.
Yeah, that is why this is a future technology.
Yeah, for the information, to validate how much it is perfect like that.
So since we don't have the high resolution satellite images, the drones we are using for a scanning purpose through the multispectral cameras or okay, this is the remote sensing, as I told. It's understanding the ground reality using the satellite images or the drone surveys like that. We're just sensing the understanding the crop. And variable rate application based on the remote sensing and sampling. So we'll understand what is the percentage of the inputs or fertilizer or spraying the green foods to be given. That will be understood. That will be fed to the drone. Okay, let's say drone only. So that pattern will be given to the plane controller. That will control the opening of the pump here. When it comes to that exact location, so it's 100%, 90%, 80%. Based on that, it will run the pump or change the speed as well. See, they may keep the speed of the pump same and change the speed of the drone. So like that, that is the algorithm how they work on that. So basically, it's a variable rate of the application. It may be the boom sprayer, it may be the fertilizer application. So all those things, and also we are coming up with one more. It's a very simple concept, but very useful for the array connector. Whatever the UGV we have parked outside, we are coming up with the automatic dispenser of the fertilizer. So the array connector plant will be there. The vehicle will be moving between that. So based on the how much fertilizer is required, so we'll have a conveyor. When it comes to that, we can set 4 kg, 3 kg, 5 kg, what is the dispensing amount. It will dispense the exact amount of the fertilizer to that. So that is what we call variable rate. So once we were able to dispense the fertilizer, easily we can control the quantity of the fertilizer as well. So that will come through remote sensing. So why I am telling the state by state we have to go means, if we are able to dispense the fertilizer now through remote, we can control the amount of the fertilizer through this. So that is how we can connect with the technology. So first thing is we have to introduce the technology to the farmers. That should be very simple. So rather than automated grid farming and all, if we come up with the UGV, nobody will take. Now how we are promoting is our UGV will comes with the similar remote. So if we push forward, means total up and down, it's moving forward, moving reverse. It's a right, left. With one joystick, you can operate the UGV. How we are marketing is, it's a replacement of the tiller, power tiller. So
it can do all the work of the power tiller. Means power tiller can do the plowing, leveling, or some other rotavator can be fixed to that. We are also working on the same attachments on this vehicle. So we just want this vehicle to work, cover all the works what power tiller is doing. That's the first target we are taking up. If you come up with all remote sensing variable rate, the cost will go high and nobody is there to purchase. I can sell to some agriculture universities where there is a funder, not more than that. So that's how we are making as simple as possible. So just one remote, they have to operate everything. And the additional technology, feature what we are giving is, they can keep the remote in their pocket. They can walk. The vehicle will follow them. So they don't have to operate it. That is there not in this vehicle. The other vehicle in our R&D that is already implemented. I have the video. See, so you just keep your remote in the pocket and walk. The vehicle will follow you. So those kind of features we started implementing it, so that the farmers should adapt to our machine, and making the machine intelligent is in our hand. First, they have to purchase the vehicle. That's the first target what we are having. Okay, this is the variable rate application. Then 5 hours of precision farming. So all when we come to this, so we can give the right input based on the requirement, because we are having a data at a right time. We don't have to wait for the skilled labor. Right rate and right time at the right place and right manner. So this is the we call it as 5 hours in the precision farming. So all these things can be achieved. So role of educational institutions, that's what I am telling you. First, we have to set the basic machines. We have to make the farmers to use the basic machines. How we can convince them? So what the problems they are facing? One is the labor issue. That's the first thing, the cost of the labor, and we are not able to do any work on right time. That is the problem. And in some cases, when we have having a discussion in some of the estates in the Chikmagalur, they are feeling that we are not worried about the cost. You give the machine, which we can replace the labor. That also, that's the next stage they are coming, and that's actually a good thing for this kind of technologies. See, one small example like that. So some 4,000 kgs of fertilizer were supposed to shift from one location to other location. That usually consumes 5 to 6 labors if they do that work on one day. So we were testing in our farmland. That guy approached me and, can you able to help us to shift this day? I told, okay, it's a case study for us, let's do that. We completed with our vehicle. That's a very off-road condition. No power tiller, no tractor cannot go in that. We just put everything loaded that 500 kg. In 4 trips we were able to complete. That happened within 45 minutes. So that has reduced almost 4 to 5 labors. So if you consider just 500 rupees, now it is more than that. 2,500 rupees work has completed within 45 minutes. Let's say 1 hour. So when I come to the calculation, so our vehicle will have 8 hours of endurance. Once we charge the battery, 8 hours of endurance. So the charge will happen, 4 hours is the charging time. So the power requirement, the current charge, not more than 10 rupees. So it's not more than 10 rupees. And the battery cost, see what happens whenever we talk about the electric vehicle, the first comment is, we have to replace the battery after 3 years. What is the cost of that? I tell you 10 rupees per hour is my vehicle cost, but you are not considering the battery cost. And battery cost is approximately 60,000 is the battery cost for the 4 kilowatt hour battery. So what happens? That can come for a 3,000 cycles. 3,000 cycles, 8 hours, 24,000. Am I audible?
Yes,
Yes.
sir.
Okay. Then it's okay. Hello. Okay. So for 8 hours of operation, 3,000 cycles, it is coming around 24,000 hours of the operation. Let's say take 50% of that, because when we purchase a new mobile, it will come 1.5 or 2 days battery. Then at the end of its life, it will come only half a day. So like that, if I take only 50%, or I'll take it as 24 to 12,000. 12,000 and the cost is the 60,000. So 5 rupees is per charge cycle. But if per hour this thing. So 1 hour if I use 5 rupees, I'll take another 5 rupees, maybe because of other charge, motor will got damage, everything. So not less than 20 rupees. 20 rupees per hour work. So whereas I am sending 2,000 rupees for the same work, which can happen within 20 rupees. And apart from that, if I add the investment cost, say my cost is maybe 4 lakh, 5 lakh, 6 lakh, something like that. So what is the interest? Even if I calculate that, it will not go beyond 25 rupees or 30 rupees. If you take same IC engine vehicle, let's assume the 1 hour of work will consume 1 liter of petrol. What is the cost of the petrol and cost of the engine, change of engine oil, the maintenance? So all these things can be brought down. That is the advantage with the, that's why, but say I'm talking only about the commercial point. When it comes to the carbon footprint, again few people will oppose the electric vehicle, I know that. So how you are going to dispose the battery? And I'm not talking here because I have to tell the disadvantage of the our own system, but that is there. But everything we cannot solve. There should be some regulation from the government as well, how to dispose the battery. That those will come with a certain cost for that. But whatever, when we go into the cost of this, whole the operation cost can be covered within 30 rupees, whereas we are spending up to 1,500, 2,000 rupees. So that is the advantage with the automation. So when we show these videos of our vehicle, when we tell the cost of this, people are ready to accept. Now we have to make the product reliable. If we sell the product without maybe like 1 week or 2 weeks, if it starts giving problem, it is a bad for the company, bad for the product, bad for the technology as well. People will not accept, farmers will not accept. That's how we have to work along with the universities to improve the product, not only engineering aspect. So what happens, I have seen personally, I'll just tell the demerits as well. Now only merits I have told. So our vehicle comes with a 0 turn radius. It will turn on the spot. So very advantage, good thing is when we plant the areca at 8 by 8, easily it can move. But the problem is, since it do 0 turn on one spot, it may damage the roots of the plant. That's a demerit. So how to overcome the demerit? The farmer has to plan where to turn the vehicle. So these kind of, some common sense, we should tell them how to use that. What may be the problem, delivering the vehicle and asking them to use, showing them to use the vehicle in what manner. So these kind of things are very important. So that's where the educational institutions also have to work for that. So vehicle is there, how to use that? What is the advantages? These commercial aspects. So once we push this to them, making the vehicle intelligence is in our hand. We don't have to depend on them. But they have to use the technology. So improving the technology we can done in the later stages. And we have to understand them, what is the importance of collecting and analyzing the data for accurate application of agri inputs, where we can save. So as per the drone application, we are saving almost 40%, 30 to 40% of the inputs. So that they should understand. Still, they are not able to accept, rather than 200 liters, we are spraying 10 liters. Nobody is accepting that. So maybe that may be a problem here. The 10 liter is not sufficient. You have to go with the 20 liters. That maybe suggestion should come from the universities to us also. So don't tell 10 liters, you tell 20 liters. That is required. You make this concentration. That is what the SOP we are talking. So that should come from the educational institution. Same way, they have to educate the farmers to use these kind of machines, so that the technology or agriculture can be improved in the. It's my opinion. I think you guys are better than me, so judging this. But like that, the farmer should accept the technology. Okay, so again, whatever the role of robotics in a precision agriculture means, again, see, whatever we speak about the precision agriculture, its roles, advantage, whatever we come, finally it will come with the resources, man resources, it will help, the productivity will be better, and cost of the overhead cost will be brought down. So these are the common reasons for those things. Okay. Okay, what are the challenges? Again, the first thing is people will not accept that one, and the land holding is very less in India. Maybe in that too in our this part of the India, land holding is very less, and spending in lakhs of amount for who is having some 2-3 acres of land is very difficult. Even 5-10 acres land they may plan for our vehicle. If you go with a bigger one, smart technology, adopting that is very difficult. Some kind of model has to be developed. Maybe the support from the government is required in this regard. So that is the biggest challenge. And there are some hackers will be there. So because the very critical thing is we are dumping all the agriculture data on the cloud, how we are protecting the data, that is also important. Who is growing what? So all this information is available on the cloud, and protecting the data is one of the very important. And the thing is, even for the drone, so it's completely can be controlled through the remote. Means not this remotely anybody can hack this system. That drone will be flying, this has a communication, flight controllers will be having a communication. If some hackers hack that, give the random input to that, what is the, so those are the certain demerits are there in precision agriculture. But people are overcoming it. There is no single case of this kind of hacking the drone as of now. So those are the things are there. But if you think beyond that imagination, there may be a hackers involvement will be there. How we are going to protect our data? So these are the concerns, not to the farmers. This is concern should be there to the government. How they are preparing the policies for that. So like that. So scope is, a lot of scope is there. In India, it has numerous opportunities for farmers to identify the better high yielding locations. So in what happens, based on the location, we can plan the crop. Once we have those data, so this is the location, this soil is suitable for these kind of crops. If the data is very handy, we can set up a market at that local area. We can ask the farmers to grow the particular crop in that area, and the marketing will be helpful, because this all like we are playing with the data. If we have the enough data, we have to process it, we have to understand it, and we have to suggest the farmers how to use that. So that's the reason the government now the government also working on the precision farming, how to see all these technologies, whatever we are bringing into the agriculture, it's a part of the precision farming only. That's why to convey here. Okay, so coming to the role of Xmatic, I'll come to the exactly our product. So you can see the product. I think this is the demo given in Devi Hosur here. Agriculture University College of Horticulture Science. So basically, this is the vehicle which is almost 4 feet 3 inches width, and 5 feet is the length of the vehicle, which can carry 500 kg load and which can tow more than 2000 kg. And it's a remotely operated self-propelled electric vehicle. It's not completely autonomous vehicle. Whatever the drone is completely autonomous, it is not autonomous, it is remotely operated self-propelled electric vehicle. So how it's a Xmatic, as I told, it is started basically want to bring a vehicle which is a similar application of a drone, how we work on the ground vehicle. That's how it is started. The main objective of this is we have to develop this product in-house, and should be a modular one. Like we have to have the attachment, different attachments, spraying systems, or fertilizer dispenser, or even it's only agriculture part I am talking. So apart from that, we have, it is can be used for fire extinguisher where there is a life risk. Maybe the defense, surveillance, ammunition supply, food supply. Again, fire extinguisher, forest firing and all, when it happens, you can send the vehicle rather than sending the human fatal accident may happen. So just rather than risking the life, we can use this vehicle. On that basis, we have started. And one thing is, it's a 100% make in India product. So we have not dependent on anything on maybe small electronic parts and all we may have to, but whole board design also has happened in-house. So coding, algorithm, everything has happened in-house. So the application, as I told, the agriculture, it's just a luggage carrying whatever we are having. So it can come with the spraying activities. And how we are addressing the challenges of the drone. Coming to again the example of areca nut. The areca nut, the advantage is it can spray above the canopy. What to do from the bottom? So that is what we are working on. That we are working on some kind of telescopic boom. So which can go to up the bottom of the canopy. We can control through the remote the direction of the nozzle. It can spray wherever it is required. That project we have started for the areca nut now. So and for the vineyard, you can have the orchard sprayer. You can plan the path. You can automate it. And harvesting also, there are some videos. I'll show it a lot. You would have seen in YouTube also. Very frankly speaking, it's some downloaded videos, not the special one. Fruit plucking robots and automating the nursery is very, very useful in this. Complete nursery can be automated. So and soil preparation mower. This is also we are working. Our next product is coming with the mower application. So just weed cutting. You can run the vehicle. I think you would have seen some videos. Some Chinese companies are working actually for this purpose also. Even Shivkumar and even have gone to Hong Kong, China and all for some spent more than 15-20 days to understand their product, their technology and where they are and what we can do. So just for that we have traveled there and understand their product as well and how we can improve ourselves. And with that we are coming up with a more application next. And is the surveillance part, even agriculture also it's required, and even for the defense also it is required. Construction industry again it is required. So where there is a labor involvement is there we can use this kind of machines. Fire extinguisher I told, in defense ammunition supply, food supply, first aid, medical support, and even you can have a stretcher. They can send the injured soldiers to the base camp. So completely can be automated. That's how we are working. So this just a concept. It is like the first concept start like this, our UGV concept. So we just wanted to have a better ground clearance so that it can move in different terrains. The concept started with the sketching and all, and different kind of platform. So what to carry based on the different platform, and we have kept a tank and HTP sprayer pump as well. So using sprayer pump, we can spray the for areca nut fungicides and all. We have sprayed that, and we have transported lot of agricultural like fertilizers, maybe harvested crops like areca nut, palm. So like that we have used for different cases, and for a different concept started like this. The different platforms, tanks mounting and all. It's actually I think the color I don't know some issue with the cable. The color is.
Permission is needed from transport department.
No, we are not using this on the road. This only, and I'll show we have a Tata Ace also parked here. Easily you can drive this onto the Tata Ace and can carry anywhere. So it's a basic. See, we are now with this platform is completely ready. Whatever the attachment you ask, we are ready to give. If you want to carry the luggage, you can. If you want to do the spraying activities, we will help. If you want to do the different like boom sprayer for different crops, different shapes of booms are required. So those also we can modify based on the requirement.
What is the cost, sir?
Cost actually it is coming around 4.5 lakhs now for the exact MRP. But for our starting few customers, we are giving it a lesser price, and also a subsidy also we are working. We don't know. So whatever we are giving, under loss we are giving, because the farmer should accept the technology. That's the only reason. And this is just a power transmission. See here we have a 6 motors, but we have 2 motors, and one will drive on the right side, one will drive the left side. Okay. So It's just to tell the specification, I'll come go in detail later. So electric vehicle, it can go up to gradient of more than 30 degree, 45 up to 45 degree we have tested. So we are committing for 30 degree now. So up to 30 degree gradient with full load it will go. So if you decrease the load again, it will go fast, go with higher gradient as well. And zero turn radius, it will turn on the spot, and it can have a towing capacity of almost 2000 kg it can tow. And electric vehicle, the BLDC motor we use, the battery is what we have used is the LFP battery. So here what battery we use? LiPo battery, lithium phosphate. When it comes to the basic two-wheelers electric vehicle, they use lithium ion battery, but we use lithium ferrophosphate, LFP battery. The advantage with the LFP battery is life cycle is better, and it will not catch fire easily. So lithium ion batteries are very risky. You have seen lot of two-wheelers got catch fire, no? So when you go and check that, all are lithium ion batteries. Most of them are lithium ion batteries. But we go with the LFP, lithium ferrophosphate, which will not catch the fire so easily. Almost all cars, automotive cars comes with the LFP battery. It's a 3000 cycles normal AC current, you can just put it will recharge. So 4 hours is again the charging based on the charger. We have 10 amps charger which will take 9 hours of charging time. 20 amps charger 4.5 hours. We usually give the 25 or 30 amps charger which will charge within 3 to 4 hours. 3 to 4 hours it will. And the advantage here is, in all the vehicle, load carrying vehicle, whatever you observe, maybe the tractor, power tiller, everything, those will carry the load behind. So this will carry the load above. That's the advantage here. So, but the problem here is the zero turn radius, which will consume lot of power in this case. So whatever we have used, almost 5 kilowatt of the power we are using in our vehicle. But actual, if you go with the calculation, the requirement is 2.5, less than 2.5. But only for the zero turn radius, we are giving more power. But that is the USP here. That is the requirement. If we give the steering, it is not so easy to take the turn and all. That's how we are giving the zero turn radius by giving the better motor. That's the advantage. It can carry that much load and go with the gradient very easily. You can see that, you can feel the torque in the vehicle. It's a remotely operated self-propelled vehicle. It may be 4.8 kilowatt, almost equivalent to 7 HP power tiller. So how much power it is having? So similar power you can get it through this. And maximum speed it can go up to 12 km per hour, but we have reduced it to the 5.6 km per hour because we have to hold the remote and go, or else we have to run behind the vehicle if we give the 12 km per hour. That's why we have reduced the speed of the vehicle. And easily gradient 30 degree it will take, and torque is more than 120 Newton meter is there. Now it is again increased to 150 Newton meter. The torque is very huge, and also it's a 4-wheel drive. So there is no question of slipping or nothing is there. Any terrain it will go. So payload is 500 kg, towing capacity is 2000 kg is there. And the first question is the PTO shaft. When we go to the farmer, where is your PTO shaft? How to connect my rotavator or this thing? We don't have answer for that. That's why we are coming up with the two options. Either we'll give a additional motor for that. They can plug it, and we'll also give the attachments also we are also working, or rotavator, whatever. We'll just connect that and use that. That's the one option. The second option now, as of now, we are giving is a separate one engine we are giving. So that engine on and off can be controlled through the remote, from the remote location. So instead of PTO shaft, they can use this engine. And that is a easily changeable one. They can use it for any other application. So like that we are coming up with a solution. Because if I want to give the output from the same, what happens, rather than 5 kilowatt, I have to go with a 15 kilowatt engine motor. Apart from 15 kilowatt, I cannot go with the same battery. Whatever the battery we are using is 90 Ah battery, which is costing more than 60,000 rupees now. To give that, I have to double the capacity at least. Then the vehicle cost will go another 60-70,000 will be extra. Rather than that, if they spend some 20,000 rupees on engine, temporarily basis it is good. If they are ready to bear the cost, we are ready to give the bigger battery. So it's not like that we cannot give, it's only the PTO is given separately just to reduce the cost of the vehicle. And sorry.
This vehicle drawing and during the moving and also during the
That is the
single RC, it is
yes, single R. And even remote we are only building in house. Now whatever here it is the drone remote we are using, but again remote also we are only building in house. Okay, 4-wheel drive, this is fine, skills clear. Yeah, remote, whatever the remote we are using is almost 2 kilometer, more than 2 kilometer range remote, but no use, that's on air, but we have tested more than 300, 400 meters it is coming, but we are promising for 200 meters only. So easily more than up to 1 kilometer it will go, but more than 50 meters it is not suggestible to use because we don't have live telecast or live camera video transmission we are not doing. It is very risk and we are restricting that in the software itself. It will not go beyond some 20 that we are just working, not more than 50 meters. Say. So see why this remote operation is required means the human will not directly expose to the chemical spraying. So you can have the safe distance, and during accident there will not be any fatal incident will not happen because vehicle may damage, that's the worst case. So operator will be safe. Those two reasons we are working. That's why what is the safest distance is required, that is what we are restricting in the software. But our remote is capable to handle more than 1 kilometer. Okay, maximum current. Hydraulic unloading is already there. So you can unload through the remote. The tipping facility is there. You can do the unloading. And follow me mode is there. So as I told you, just hold the remote and walk. It will come behind you. Loading is manual. Again, for that also we are working, but we don't use the actual use cases. Let's see, we can have some conveyor and load it, but there are certain earthwork. We have to take the soil and dump it somewhere. No, for that self-loading, its solution is there, but we are not finding it so commercially viable. So if it is viable, we are ready to give. But in this vehicle, it is not there. And the boom sprayer based on the application, what is the shape required, what is the motor, these kind of pumps or HTP pump, because the problem with the UAV is the weight. Even for 50 gram also, Shukumar will cry if we can't put the more weight and all. But in our case, that is not a problem. Even if the price is less, even 2 kgs extra, we are ready to keep it on this. That's why the pump, even we give the HTP pump with 350 is the one, actually it should be a 400 liters tank, the 2 barrel of medicine, maybe agri inputs. So usually when they spray 400 liters based on the customer requirement, we'll give this also. And platform, flat platform is required for vineyard to harvest the grapes and all, it is required. So based on the requirement, we give the platform. It will come with a one fixed platform, whatever we see here. So apart from what kind of platform is required, based on the its accessories, they based on their requirement they can. And this is one which we are working. It will come soon. Fertilizer dispenser. So through remote itself, you can dispense the fertilizer. So later we can automate it also. So we are working on detection of the tree algorithm. We are working on the software part. Because when we spray this on mango and all, it will just spray between the trees also, where it is not necessary. We are working on automating that, where there is a tree, it will just detect and do the spraying. Similarly, fertilizer dispenser also happened. Where there is a tree, it will just dispense the fertilizer. Granule dispenser and orchard sprayer. Orchard sprayer, the problem is again the power. Here in orchard sprayer, we can run the HTP pump, but running that blower fan is very difficult in our case. So we may have to have the separate engine for the orchard sprayer. We are working on that for the vineyard. So here, the same features just with the images kept. Okay. So orchard sprayers, some kind of boom sprayers, and mower application. So all these things will come as a attachments for the vehicle. Okay. Now coming to the technical part. So as morning discussed the motor, this thing, just I'll go in brief about that. So here also components, we have a motor, battery is there, vehicle control unit and motor control unit. So it is in, when you compare with the drone, it is a FC and it's a ESC. Motor and transmitter and receiver, same remote will be there. Spraying systems will be there. The bigger one, here it is a smaller, there bigger one, more attachment. In a wheel we have three types. Normal tire wheel is there, track wheel is there. That is also we are easily replaceable. For the same attachment you can fix the track also. That also we are working. And cage wheel. Cage wheel, wherever it is requirement, they can use the cage wheel as well. Emergency brake, this is the one technology we are working. So when there is a problem with the any hang or if water spills on the controller and it is IP graded only, it will not damage. Even in case something happens or rat bite, because of the rat bite, controller will lose the contact, battery will damage, something, whatever the things happens, automatically we'll have a auxiliary battery which will apply the brake and stop the vehicle. So whatever the, there will be some defined condition. Apart from that, if anything happens, this emergency brake will apply. So, so these things are there. And coming to the components, similarly, we'll have a controller, transmission shaft will be there, the motor will be there, battery, DC-DC converter, power inverter and charger. So it's for automotive. See, now I am comparing this with the electric vehicle. So till now we are comparing with the UGV. So what happens there, similarly the controller will be there, that's a vehicle control unit, and transmission, what we told, the chain that you can see in the vehicle, and the motor will be there, the battery and DC-DC converter is required because we have a battery with a 48 volt and some of these things are works with a different voltages. So this may pump may work with the 12 volt, lights may work with the 24 volt. So based on the requirement, we'll have a DC-DC converters will be there and power inverters will be there. That's what the control unit, and the charger will be there. So charger also based on the requirement and charging speed, we give the charger. This is a similar motor, BLDC motor, or we call it as PMSM motor, permanent magnet synchronous motor. So here also the rotor will be in center and the stator will be outside. Same one with a bigger, slightly different, same magnets will be there. So that will comes with a controller like this. And also the advantage with this will come with the brake also. So in this UGVs that doesn't require a braking system. That is the advantage. We don't need a steering system. We don't need a brake system. A braking system. We don't need a steering, and suspension also not required in this compared to automotive. But that braking can be applied through the motor itself. If I tell the motor to hold it at 0 RPM, it will hold it at 0 RPM. It will not turn. But the only case is when the battery wire got damaged or some controller issue is there, vehicle simply start moving in the down. So that's why we have a additional brake, that's an emergency brake. And these BLDC motors comes with a very high torque. That's the reason all automotive application they go with the BLDC or PMSM motors because of the high torque. And lithium, as I told, we are using a lithium ferrophosphate battery, not the lithium ion battery. Battery capacity is 48 volt is the nominal voltage, and the 90 AH is the 90 ampere hour is the battery capacity. And it is like we'll have a cells like this based on the requirement. We can arrange the cell and give. It is very simple now. Whatever that's this all the single cells based on the requirement. We can connect it serial or series or through parallel, and we can make the battery. Okay, I'll show some videos now. Let's start with auto speed.
Track turn automation, you can. Our innovative solution automatically controls the entire raising or lowering of linkages at exactly the right time and position in the field for a perfectly consistent crop growth and health at headland. Turn automation integrates John Deere AutoTrack automatic steering and headland management into 6R to 9R tractors, reducing input costs for seed, fertilizer and fuel. Turn automation manages all tractor and implement functions with ease and precision. With the new intuitive Generation 4 displays interface, setup is easier than ever before, showing you which steps you've finished and which ones are left to set up. Easily change turn direction or the number of skips and preview upcoming turns. Even the most skilled operators benefit from this automation. A perfect headland turn every time. Get ahead with AutoTrack.
partition has to be done like this. Based on this proposal, we divided according to this.
Then you were telling about this harvesters.
Ha.
Is it possible to have a multi-purpose that is small size pepper seeds reserved for
Pepper, it is actually difficult, but actually we are working for a areca nut. So completely telescopic one, and focusing the bunch, areca bunch, and spraying activity as well as harvesting. Coconut can be done, no problem. Very small, and it should not damage the crop also. No, that is the concern. We have not tried. Frankly, we are not. Ah. Okay, okay. Oh, yeah, there. Yeah, yeah, yeah. No, that is there. See, thing is, copy it. The thing is, the vehicle now, the platform is ready. The application wise, we have to work now. ಇಲ್ಲಲ್ಲ ಪೆನ್ ಡ್ರೈವ್ ಇದೆ ಹಾಂ ತೆಗಿ
another thing is that whether it is possible using this UGV to get rid of wild animal problem.
Yes, yes, easily. It's a complete, you can completely automate it. So it, hmm, correct. In your region, it is very difficult. So it can be done. So if we have any specific path, it will go to that path and do whatever the activity, surveillance, make some sound, or if it again, if it detects some animals, then only it will make sound. So these kind of thing also can be done.
With respect to artistic sound erasers,
Huh.
in due course of time, the animal gets.
Yeah, just to that. So we, correct, correct. No, anything like that. Say maybe what it has done. If you suggest, we are ready to do that. That is doable. I'll play different videos. Okay, this is the first version of our video. Okay, play ಮಾಡಿ ಪರವಾಗಿಲ್ಲ. This first version is now. This the vehicle is okay. Final life. The above part is now changed because for the aesthetic requirement only, nothing else. Next to close ಮಾಡಿ ಇದು. Play ಮಾಡಿ. This is used in the for just spraying. This is also a first version of vehicle. Just during the development stage, whatever we have done, the spray. This is with a boom we can do it automated. Just for trial purpose we have done all this. This is less than 8 by 8. We don't have a professional videos, but some. This is taken in UHS Bagalkot, just to showcase the vehicle inside the vineyard, how it will be. So nothing kept above the vehicle, it's just a platform. So harvesting, fertilizer, taking fertilizer, we can use it. Based on the end user requirement, we can modify it. Just we wanted to show we can do the zero turn at that constrained space without damaging the crop. Just to demonstrate that the dimensions of the vehicle, how we can use. This is a R&D vehicle, that's why you can see the vibration and all. But whatever the vehicle we are having now, it's completely okay. A similar one. This is 8 by 8 reconnect. See, there you can notice there may be a damage in the root. So those should be avoided. That's the observation we have done actually. If you just move, nothing will happen. If you do the zero turn radius, that will damage the root. Now we'll just go with some technology videos. Present trends. So yeah, go with the present trends first. That one, okay. Okay, it's okay. I think you will not get the audio. That's all. Okay. video. These are some Chinese companies robots. Boom sprayer. The problem with this is when there is no crop plant also, it is simply wasting the inputs. That is, we are again automating. We are keeping some sensors and identifying the crop and we are spraying it. This will solve the question like whether it's spray that under the canopy, under the leaves. So whatever you notice, the demerits of the drone should be addressed by these technologies. Yeah, we can use in rain also. Yes, all season. Night also you can operate, no problem. So all our electronics comes with the IP grading, IP65 to 67 it will be there. So next again continue, sir. Let's see, whatever the videos now we are showing is the existing technologies. These are the existing machines and how we are improving. So we are with this similarly application, we are ready to give the products now. This particular robot comes with the engine. It's not an electric one. That's why they are able to give the orchard sprayer easily. Similarly, this path planning can be done in our vehicle as well. So with the archer sprayer running this blower with the electric motor is very difficult. More than 1.5 feet ಇದೆ. This is a crawler tape. The problem with the crawler tape is rolling resistance will be more. So battery range will be very less. That's why we avoided that. We are coming up with a new type of belt that can be fitted on the tire, so that you can convert that to the crawler. This is also with the 0 Newton? This comes with the 0 turn radius. See, same HTP pump they have used here.
Whether it can be used inside the poly house?
Inside?
Inside the poly house.
Yes, can be used. So this is the automatic mower application. Mower. That comes as an attachment for our vehicle as well. But here the challenge is demonstrating like this is easy, but when it goes to the real condition, there are a lot of rocks will ups and downs are there. That we are working based on how to vary the mower height. Yeah, that's what we are working on. That's why we are not releasing that to the market now. But all the attachments, whatever we are developing, that is compatible with the vehicle, whatever we have delivered. This is a very good one. It's actually Bangalore company. They have done a very, very good job. They're just scanning the crop and spraying. There is no continuous spraying. You can see that. This is the next version of the spraying. Yeah, on the spot, they're analyzing it and they're just spraying on the spot. This will save a lot of green input. See. This is the one we are also working now. So our vehicle will similarly it will come like. Sewing machine we have, there are some machines are there, but we have not started working on that actually.
Some machines are there, unrent or
Yes, it's there, but not in India. India, I think the follow me mode, we are the first one to introduce that follow me mode. I'll show some video. Yeah, similarly, we can load it to the truck and unload it. Transportation is very easy. This is actually XAG company, very well-known company for even for drone also they are very good now. Frankly speaking, we have benchmarked their vehicle. Means through YouTube video, we have not brought it and checked it. So that concept, our concept, we also taken from them actually. This is the RTK module. That's what we are discussing now. But see, their capacity is the around 150 kg payload capacity, but ours is it is 500 kg. What they will do is they will just walk on the path so that they will take the they will make the path planning and then they will automate it. And this kind of spraying, I don't know, you have to suggest me. I don't think this will not spray uniformly. It will like some sinusoidal wave. So we have to have uniform spray, means it should be, that's my opinion. Sir?
it should be on the spot.
Yeah, on the spot. So those are, see, that's why first if we able to sell the machine, we can make the machine intelligent later. So those things can be done. Sorry? Sorry?
It's the Vietnam model of growing factor. Instead of life standard, they use this machine. No, it's only, but we are doing the life standard. It is gaining popularity. It can move in any condition, soil.
Yes. It's actually quite smaller compared to ours. Videos back. One second. ಅದು ಮತ್ತು ಆಟೋ ಸ್ಟೀರ್ ಆಯಿತು. ದಿಸ್ ಇಸ್ ಪ್ರಿಸಿಷನ್. I'll go to the precision farming only. So this is about the precision farming.
agriculture is a method in which farmers optimize inputs such as water and fertilizer to enhance productivity, quality, and yield. The term also involves minimizing pests and diseases through spatially targeted application of precise amount of pesticides. It means that you will deal with parts of the field So what exactly is precision agriculture and how is it different from traditional farming?
Traditional agriculture where everything has started. This is actually from experience handed over. Technology has also improved, so they started with animals in the beginning, they built up machines, tractors and so on, and then they realized, okay, if I'm more precise on planting, harvesting, fertilizing, then I actually get also more out of my fields. And this is exactly difference, where precision makes a difference in the efficiency or in the productivity of the farm. And this where precision agriculture is actually only a driver or measure another level of productivity in agriculture.
Precision farming is a farming management concept based on observing and responding to intra-field variations. It relies on new technologies like satellite imagery, GPS, information technology, and other geospatial tools. Let's try and understand this better. Suppose you have 20 hectares and you are getting 100 tons per hectare of yield. A remote sensing image of your field shows the difference between the yield in various parts of the same ground. Areas marked in red show the yield of 20 tons per hectare, while areas marked in blue show yield of 120 tons per hectare, a difference of 100 tons. Or in other words, not optimizing yield from these 100 tons is leading to loss in productivity. Observing variability in a crop is the first step of precision agriculture process. Evaluating all this information together can give you a better understanding of the causes of variability in your farm. Depending on evaluation, you can manage your crop better. Sensors in field measure the moisture content and temperature of the soil and surrounding area. Satellites and robotic drones provide farmers with real-time images of individual plants. Information from those images can be processed and integrated with sensors and other data to yield guidance for immediate and future decisions, such as precisely what fields to water and when or where to plant a particular crop. For example, it can give you an idea if you need to apply a particular mineral or fertilizer in one area of your land rather than using it in the entire farm, thus saving you money, resource, and time. Geospatial science has a major role to play in securing both food and nutritional security in agricultural systems. Geospatial technologies such as GPS, GNSS, remote sensing, and drones play an important role in precise location of problems, optimizing resources, and maximizing yield.
This is higher precision GNSS, which actually only enables a 1 to 2 centimeter accuracy to really bring this precision also down to the field to the crops where they actually need it to get the productivity. On the other component or the other technology that you need is also, of course, also the machine together with the tools that we have in the back, that they are adjusted and calibrated to each other, because the position that you measure on the roof is not what the farmer is interested in. He is interested in the centimeter on the ground down there. So you have to know what is the distance between these 2 points to make it really precise as an entire thing.
Unmanned aerial vehicles or UAVs allow farmers to monitor crop and livestock conditions consistently by air to find problems that would not be visible in ground level spot checks. An apt example, a farmer can inspect whether his crop is not being properly irrigated through time lapse.
But we're also seeing the increasing growth in agriculture,
So that's using different sensors like multispectral sensors to basically fly over the crops and measure the reflections of the light, seeing where the crops are healthy and where they're sick. Today, mobile apps, smart sensors, drones and cloud computing make precision agriculture possible for farming cooperatives and even small-time farms.
Agricultural robots automate slow, repetitive and dull tasks for farmers, allowing them to focus
So this is the harvesting robot.
Some of the most common robots in agriculture are harvesting and control. Let's have a look at the most advanced robots. When we need them, Pebbles Control Center sends the technicians with a fleet of pickers. After a short setup, robots select, pick, and box only ripe fruit ready for market. With robots working day and night, the applications provide real-time updates on harvesting progress, time to completion, quantity picked, and cost. This is our future. Crops such as potatoes and wheat have been harvested mechanically at scale for decades, but many other crops have to date resisted automation. Iceberg lettuce is one such crop. Although it is the most common type of lettuce grown in the UK, iceberg is easily damaged and grows relatively flat to the ground, presenting a challenge for robotic harvesters. The vegetable, developed by a team at the University of Cambridge, was initially trained to recognize and harvest iceberg lettuce in a lab setting. Although the prototype is nowhere near as fast or efficient as a human worker, it demonstrates how the use of robotics in agriculture might be expanded.
These are the future technologies, not food itself.
Meet Volodrone from Polyculture. The Volodrone increases productivity in the areas of plant protection, seed sowing, forest management, frost control, and more. Sharing strong synergies with the existing Polyculture platform, the Volodrone presents an unmanned, fully electric utility drone capable of carrying an unprecedented payload. The Volodrone has been designed and engineered to serve challenging missions across diverse industries, adding the third dimension to sustainable transport. The Volodrone is a fully electric heavy-lift utility drone capable of carrying a payload of 200 kilograms, 440 pounds, up to 40 kilometers, 25 miles. AgSeed is launching a track-based active autonomous tractor for specialized and standard implements. Working widths are up to 6 meters, depending on the type of implement used, and the track width is up to 3.2 meters. The vehicle is powered by a 156 horsepower 4-cylinder diesel engine that drives an electric generator to power all actuators, drivetrain, PTO, fan. Navigation and planning takes place via cloud-based software that automatically generates path planners based on the field's geofences and machine specifications. The biggest advantage is that the AgSeed Agrit can be used straight from the box. No special implements are required, nor special software on your home computer. AgSeed deliver a ready-to-use ecosystem that avoids compacting the soil by providing very low ground pressure. Another solution, autonomous sprayer from John Deere. When entering a field, a scout drone is released to scan weeds from the air. When it returns to the test box, weed information is shared, anything from 3 minutes to 2 hours, with other drones, all of which, like the first one, can scout and spot individual weeds. The base of the structure of the 2-drone system at Agritechnica contains a 1,000-liter water tank and 3 60-liter chemical tanks. Flight time with a fully charged battery is 30 minutes, and when it needs charging, or the drone's 10.6-liter tank needs a top-up, it automatically returns to the test box. The landing pad retracts automatically, and battery swapping and tank filling are also automatic. All current work has been done with water at a John Deere test ground in Field Club. crops of maize, corn, and cotton. Claimed benefits include the precise application of pesticides, a significant reduction in the volume used, and spraying from the air allows crops to be treated on wet land without damage. Strawberry picker Rubian from Actinium. If a robotic picker could delicately select perfectly ripe strawberries without the stemmer bruising the fruit, sort them based on weight, place each in a box, and do so at a rate that matches the human picking cost, implementing a technological solution would seem like a no-brainer. In some cases, however, cost, capability, and crop type are not the only barriers to picking robots the market is. Actinium's Rubian sets itself apart from the competition by delivering a new solution to an essential issue plaguing other strawberry harvesters: the stems. Most robotic pickers select the stem to avoid touching the fruit, which means the fruit must be packaged with the stems facing up. Actinium notes that picking by grabbing the stem delivers a low-quality crop. They also believe that packing with the green side to top facing up looks terrible to consumers. Their approach is to produce a robot that can pick the fruit and package it with the top down. Autonomous electric tractor from John Deere. John Deere's new autonomous tractor concept is a very compact electric drive unit with integrated attachment. The tractor has a total output of 500 kilowatts and can be equipped with either wheels or tracks. Flexible ballasting from 5 to 15 tons is possible, depending on the application, to help reduce soil compaction. Thanks to the electric drive, there are no operating emissions, and noise levels are extremely low. Further advantages include low wear and maintenance costs. Thanks for watching. Subscribe and turn on the bell to hear about our latest videos if you haven't done.
Okay, any doubt, or we can move to the vehicle demo?
Thank you, sir. We'll break for tea, then we'll go down and we'll see the practical, the operationals of this UG unmanned ground vehicle. Then we'll reassemble after the practical class. From then we can disperse. Okay. So after completion of practical, we'll come back here. Okay. Thank you. Now it's 4:30, so we can have 15 minutes break for tea. Then we'll reassemble at 4:45 outside this main building.